Isomerism is a part of general organic chemistry that actually always instigates students, because beta, technically if you talk even for a JEE mains paper, it is strictly based on NCRT. Sir, NCRT class 11th has GOC as well, but yes, the merger between a concept of isomerism with the concepts of NCRT organic chemistry makes the question good. Although this was started by JEE Advance, but once Advance has started doing it, mains have followed the suit. And you know what, this time even NEET examination gave a paper where you have to determine the RS, the stereo-isomeric optical orientation of a Newman projection, also of a Fisher projection also. So I hope everybody must be in sync with this idea that a question becomes a good question if bundle of concepts are mixed. So now I'm directly talking to all my Lux JEE students, because beta, yesterday I have not taken this lecture, rather because as we have done a polling in the previous class, most of you said, sir, not all the homework questions are complete, and I completely understand, because sir, if we are a class 11 student na, then definitely we have lots of time, sir, because we have to start alkyl halides also. But sir, alkyl halide and even all the organic chemistry chapters beta, they require this logic of stereoisomerism, the isomeric, so especially the stereoisomer, the optical one. Now, in our class, we have already finished with structural isomerism and geometrical isomerism, coupled with conformational isomerism, the pseudo isomers, the non-true isomers. So let us quickly revise everything. Yes, it is going to be a extended session. That's why I have taken a separate Sunday class, so that all my Lux JEE students would also have a frame, that obviously they feel exhausted if any student have to attend 2 lectures or maybe more, it becomes a tedious task. So I hope this Sunday morning has brought you with a fresh frame of mind, where you are able to sit and solve questions. So today I will not be giving any homework. Whatever questions we'll be having, we'll be practicing those questions in this class only. So let us try to complete most of it. The only thing I will be leaving for isomeric questions per se are just that mains level of questions, where we have to calculate the types of the total number of isomers. Why? Because obviously the total number of isomers calculation, those questions have become very prominent, very probable. Yes, we will not do them. We'll definitely do them, but yes, we'll push them with the basics of once we'll start with class 12th alkyl halides also. Hai na? So I hope everybody is doing great. So let me just see who all are there with me. Yes, good morning Ashlesh, good morning Gayatri, good morning Krupa, good morning everybody. Yes beta, this along with you have got some more friends who will be joining us live from YouTube. And at YouTube we have Anita. Anita, hello beta. I hope everybody is doing great. Now let us start the session with the revision first. Sir, we'll let us first revise, not theoretically, with questions, है ना? So I hope everybody is doing great. Yes, good morning Shahawat Tripathi ji. How are you doing, sir? Yes, I'm doing great. On a Sunday especially, I'm doing awesome. Chalo beta. Vittal, good, hello. Yes, so let's begin beta, है ना? So everybody please make sure you are focusing, you are giving each and every amount of your attention over here. Be ready with your pen and copy, and let us start. So my Lux students, do not worry. Why, sir? Because I will not be giving homework today, because I've seen obviously. But beta, I just request each and every one of you, beta, please revise the previous classes very, very properly. Do not leave the questions that I've given you as homework. And now in this class, I'll not be giving any questions. Let us practice all the questions together. And yes, definitely it'll take time. No issues. If even I will require some bio break, we will even take some 10-15 minutes bio break, and then we'll continue. But I'll try to wrap the session. आफ्टरनून नहीं बेटा 12 is morning only है ना so the comment screen just got froze yes so now I can see everybody and I can see the comments too chalo sir is the same lecture live yes, Gayatri. Because we have came to a topic which definitely is important, the concept of stereoisomers. So rather, I have made the session public for everybody, so that everybody can, who anybody who want to join and have a feeling of what content we are actually reading in a class. So let us discuss everything with everybody. है ना? Archana is asking, sir, class will be till beta. It will be a 3-hour class, maybe more, depending the number of questions, how we are trying to deal with it. If more doubts are there, then definitely a thorough discussion I'll do. है ना? Chalo, let us be calm and try to gain something in the following hours. So first of all, we'll discuss some problems on stereoisomerism, and then we'll start optical isomerism again, because I guess the last class that we had, because of some technical glitch, although we have covered most of it, but yes, the last 10-15 minutes which I wanted to take and give some homework accordingly, that was missed. So let us again give it a fresh start. है ना? Chalo. Sir, I missed the previous lecture due to exams. Can I continue with this? Yes, Ashlesh, no issues, but try to cover that after this class. है ना? Chalo. Sir, let us quickly revise isomerism briefly. So, beta, isomers are basically compound having same molecular formula, but if they have different structural formula, as in the IUPAC name is also different, so they are structural isomers. Sir, we know this. Sir, we know this. And if they have same molecular formula also and same IUPAC name also, as in they have same structure also, then they are called stereoisomers. So what are stereoisomers? So structural isomers have same molecular formula but different structural formula. Stereoisomers have same molecular formula also and structural formula also. But what do they differ in? Sir, they differ in their stereochemical formula. Sir, what is the stereochemical formula? Beta, the orientation in three-dimensional space. The orientation in three-dimensional space is different, and that's why they are called stereoisomers. Now, sir, the stereoisomers are generally of two types. One is called configurational, which are actually two different compounds, two or more different compounds, and the other one is known as conformational. Conformational. Now, conformational isomers also we have completed. What are conformational isomers? Sir, they are actually the same compound, but the amount of energy that they require to interconvert into each other is very less. Hence, even at room temperature, that energy is supplied. So that means they are not two different compounds, sir. They can easily convert into one another. So they are one compound, but that one compound, if we do the energy profiling, we see that they have different orientations in three-dimensional space, and hence they are satisfying this definition of being a stereoisomer, but they are basically one compound only. Hence, these conformational isomers are known as false isomers or pseudo isomers, because they are not two different compounds. They are one compound which is converting into one another. But doing the energy profiling, we can definitely analyze them, that how they are existing in nature. है ना? So please start poll. हाँ beta, definitely Gayatri, I'll start poll. Do not, no issues. I will be doing the exactly the same thing that I do in my class. So rest assured, है ना? चलो. So, sir, conformational isomer done, as in the conformational isomers of all the alkanes, because there is no restricted rotation, so alkane can freely rotate, and because of the free rotation, many stereoisomers, as in many isomers exist in nature which has same molecular formula, same name, same structure, but orientation in three-dimensional space is different. In order to represent them in a copy, some projection formula we write for them, which is sawhorse projection, Newman projection. So you are telling telling everything, not giving any example. Beta, I'm just giving a brief. We'll be discussing each and everything using questions, but using questions, है ना? चलो. So they are pseudo isomers. Done, sir. So that means that configurational isomers are actually two different compounds. Yes, they are actually two different compounds. And when two different compounds which exist independently in nature have same molecular formula, structure formula, but different three-dimensional orientation as in stereochemical formula, then they are called as configurational isomers. Now, configurational isomers are basically further of two types. One is geometrical. Other one is optical. What are geometrical isomer? Sir, when you have different orientation in three-dimensional space as in different stereochemical formula, but that difference is arising because of a center. That center in that particular compound is known as a stereo center. What isomerism is arising? Geometrical isomerism. So it is termed as a geometrical stereo center. So if I can exist in two different forms, if I as a molecule can exist in two different three-dimensional orientation, then I need to have a center which can enable me to show those orientations in three-dimensional space. That restricted rotation center is termed as a geometrical stereo center. Sir, what are the examples of geometrical stereo center? The famous example for us are whenever we have a pi electron cloud like C double bond C, because technically C single bond C is free to rotate. There are tetrahedral structure, so three bonds. They are free to rotate, hence conformation exists. But if you just tie my fingers like in pi bond, after formation of sigma bond, once pi bond is formed, the restriction gets restricted, the rotation gets restricted, and because the rotation gets restricted, so whatever orientation because the double bonded carbon will be a trigonal planar species, and that trigonal planar species has some groups at the top, some groups at the bottom of the triangle. Then sir, the species which are all at the top will always remain at the top because the pi bond is always formed. If the compound is reacting, then only the configuration can change. And definitely how to name them. For naming geometrical isomers, we can name them cis, trans, we can name them E, Z, so on and so forth. Sir, how? We'll practice questions now. Coming to optical isomers, sir, optical isomers also have same molecular formula, same structural formula. Then where do they differ? They differ because they have also a center which enabled them to show stereoisomerism. Now what is that center? That particular center is known as a optical stereo center, as in a center because of which the optical isomerism arises. Now first of all, tell me what is optical isomerism. Just to give you a briefing regarding the optical isomerism, regarding what are optical isomers, if we have a source of light, this source of light is passed through Nicol prism and then through a system of slit and prism, then the light from a source is non-polarized, sir. It will be going in all the possible directions, but a prism called Nicol prism, which is part of a system in this polarimeter, this makes the non-polarized light a polarized light. What is a polarized light? Which is just directed in a one single direction. So the perpendicular path will be the plane of that polarized light. If that polarized light is passed through a solution and the cylinder is filled with a solution, and if this solution is containing an organic compound which has a capability to rotate this plane of a polarized light. Sir, why you are interested in plane? Because ultimately the polarized light will be getting rotated, because through the eyepiece whatever we see, we just observe the plane, the perpendicular plane of the polarized light, and that perpendicular plane of the polarized light gets rotated. If it is getting rotated, then that means the compound, the solution that I've taken in my polarimeter has a capability to rotate that plane of a polarized light. Then that compound is termed as optically active. Else it is obviously optically inactive. Now if it is optically active, its optical activity can be only observed as it can either rotate the light in clockwise direction, so it will be termed as a dextrorotatory compound. If it is rotating light in anti-clockwise direction, then it is termed as levorotatory. Sir, if you are optically active as in dextrorotatory or levorotatory, ultimately that means you will be having some center that is receiving light and rotating that light in a particular direction. Sir, if a compound, whether a compound is dextrorotatory or levorotatory, can be estimated how beta, it can only be estimated through this polarimeter experiment, not otherwise. Scientist community have done all these experiments and have gathered this conclusion that whatever compounds who were having the capability to rotate this plane of a polarized light, all these compounds also had some asymmetric center. Now, the another word that I'm mentioning is an asymmetric center. So what is this asymmetric center? Asymmetric center, by the name it is suggesting a center which is making the compound to have no element of symmetry. It is not at all symmetric from anywhere. Sir, then how many asymmetric centers exist in nature? Sir, shall we know all those asymmetric centers? Again, practically for our JEE syllabus, the most famous asymmetric center is a chiral carbon. Now, what is a chiral carbon? Chiral carbon is an sp3 hybridized carbon, as in a carbon which is making 4 sigma bonds, and all those sigma bonds are differently substituted. And all those sigma bonds are differently substituted. That is the famous example of an asymmetric center, an optical stereo center, the chiral carbon. So, do we have some more optical stereo centers? Yes, we have allenes also, biphenyls also, but we'll be taking them in questions. Let us do the just briefing of optical isomerism in the beginning, and definitely we will build the confidence with attempting more and more number of questions in this particular class. Now, sir, coming to the optical isomers, sir, because they have same molecular formula, sir, same structural formula, sir, they have all the same physical properties. They can, sir, then how can you write, if they have everything same, then how can you write them in a 2D copy? How can we write them in our copy, sir? For that, some projection formula are again given. The best and famous projection formula is obviously Fisher projection and wedge dash projection. Technically, we will go for Fisher projection. Sir, how to draw that Fisher projection? Definitely, the true Fisher projection has the main chain in the vertical line, and whatever tetrahedral carbon has branches, they are drawn in the horizontal line. Technically, the Fisher projection is drawn with an idea that the horizontal bonds are towards you and vertical bonds are away from you. Sir, we didn't get this. I have just given this briefing for all those students who may have a clue of it. If you are clueless regarding it, obviously that also we'll be doing it with the later slides. Now, I'm just initially giving all the briefing because technically we are learning this as a class 12 students, just in order to enable us to use these concepts directly to solve questions. Now, sir, that means now we know that you can, yes, we will learn how to draw Fisher projection, but once we can draw the Fisher projection of those isomers, the two optical isomers we can draw. Yes. The two optical isomers, if you draw their Fisher projection, they will be a mirror image of each other, and these mirror image Fisher projection optical isomers are also termed as enantiomers. Sir, if they are not same, then they are termed as diastereomers. So what are diastereomers? First of all, what are enantiomers? Enantiomers are optical isomers which are mirror images of each other. What are diastereomers? So diastereomers are stereoisomers which are not mirror images of each other. So if I am not a mirror image of each other, obviously I will have different physical properties. So that means you can easily isolate those compounds. But sir, enantiomers have all the same properties. That means enantiomers have all the same properties. The only property they differ is their ability to rotate the plane of a polarized light. So enantiomers have all the same physical properties. Only one physical property is different. That is their ability to rotate the plane of a polarized light, which can only be determined through experiment. Now, Sir, that means diastereomers are different. That means, sir, if we have geometrical isomers, then geometrical isomers are also stereoisomers. Yes. And if geometrical isomers are also stereoisomers, sir, that means they are stereoisomers, not mirror image of each other, having different physical properties. That means cis and trans, the geometrical isomers are also known as diastereomers. Now, let us now, sir, practice of whatever you have said. Sir, okay, I just know some briefing regarding stereoisomers, so I got it. Because I'm not trying to make this lecture theoretical, because we are not going to write a theory examination, sir. We are going to crack JEE, and JEE requires ABCD type of questions to solve. So I've just given a briefing for each child. Even if you have like Ashlesh or whatever students who said, sir, I didn't attend the last class, so I'm just giving this briefing for all the students to come in sync. Now let us start practicing questions around it. And while practicing question, I will definitely be giving you all the remainder of the details so that you can have that particular level of confidence for isomerism involving general organic chemistry. Chalo. So the first question is in front of you, because we are discussing stereoisomerism essentially per se in this lecture. So sir, stereoisomers, non-true are conformational isomers. So let us revise conformational isomers again with a bit of questions. So the first question is in front of you. Let me start the timer so that everybody can feel relatable. Take out your pen and copy and attempt this question. Everybody attempt the first question that is in front of you by the time I just set the comment screen, because I cannot see comments from every student. Yes, now I can. So great. Sir, acha. Okay, sir. Jai Hind, sir. ND aspirant, BBB. Michelle is asking, sir, will it become 6-hour lecture like in YouTube? Michelle, nahi, not 6-hour lecture. But yes, it will be extended beta. I guess 3.5 hours. Let's see, hai na? Michelle, that's why I've chosen to merge this particular class. Sir, 1 and 2 are same. Okay, so let's make it Q and P. Thank you, beta. Yes, they were same. So A is Q, B is P. Then options are different. So at least you can try. Anna? Chalo. Obviously, sir, with this question, we are just trying to revise the conformational isomer. So what is A? Sir, A is this. That means if you just draw it, how to draw this? Sir, this is the first carbon. First, this is the front carbon. This is how. So this is a Newman projection. This is called a Newman projection. Now, this is my front carbon. So this is my front carbon. Let's say I'm drawing this carbon as C. It is having one CH3 and two hydrogen. So two hydrogens and one CH3. Now, it is connected with the back carbon. This is a back carbon. This is a back carbon. This back carbon is not being attached with anything. So I guess this back carbon is a misprint, because obviously it is not substituted with anything, or else it has to be question has to give us what is that thing. So let us assume that it does not exist, because it, sir, if it is carbon and if Newman projection is shown, then technically how you show this Newman projection? Let me draw this Newman projection again for you. So this is the front carbon having methyl group. Sir, two are hydrogens. Then this is your front carbon. Then you have your back carbon. Back carbon we draw as a circle. So considering having a feeling from the question, it is showing that methyl as in CH3 is at the back for the back carbon. Hydrogen is there for the first one and for the second one. So obviously that green carbon you have to just assume that it does not exist, because I guess that's a printing, that's a typo error. But now definitely why this is what, sir? Sir, when groups are just eclipsing each other, then this particular form is called as an eclipsed form. Obviously, because these bulky groups are very, very close to each other, so it's a fully eclipsed form. It will have highest potential energy. Why? Because of it will have highest potential energy. Why? Because of high van der Waals strain. What is van der Waals strain? The strain because of crowding. So this guy will have highest crowding, and because it is having highest crowding, so it will be having highest potential energy and least stability. So this A is definitely my eclipsed form. That means A is definitely P. So two options are gone. Now, sir, what about B? Now B is also B is having this CH3. Then I already said you do not have to see just this carbon because it is not showing any three different bonds. So that means this is my back carbon. This is my back carbon having H, CH3 and hydrogen. So this is my hydrogen, this is my methyl, and this is my H. So this is definitely B, and this B is, sir, CH3 is and H are eclipsed, sir. Sir, CH3 and H are just superimposing each other. But sir, the picture is not showing exact superimposition. Sometimes beta, yeah, technically if they are exactly superimposing each other, if you're viewing it from this side, then that's an eclipsed form. If it is having an angle of 60 degree, that means it's the most stable staggered form, because torsional strain, as in the repulsion between bond pair electrons, will be minimum. But sir, if the angle is between 0 to 60 degree, which is obviously evident from this photo, then all those forms are called skew form. Do we have skew form in the options? No. So that means you do not have to consider that skew form. This is how you can predict. Even your question is giving you a representation of structure like this, then also it can be either eclipsed or it can be either scattered. It can either be staggered. Sir, it can be skew also. The angle can be 0 degree or 60 degree. It can be in between 0 to 60 also, sir. How come you said that it is only eclipsed? Because beta, skew is not there in the option. So that's why you do not have to consider skew form. Now, so that means it can only be eclipsed and staggered, and that means, sir, CH3 can't completely eclipse hydrogen. I mean, CH3 can, but hydrogen can't completely eclipse CH3 because that's a bulky group. So this is also an eclipsed form, but partially eclipsed. So that means B is definitely Q. So sir, this is just the same, sir. B is Q. So here B is S, here B is Q. So obviously we have got our answer, but because we are learning, this is also a staggered form with 60 degree dihedral angle. This is the dihedral angle theta, which is exactly 60 degree for a staggered form. So this is also 60 degree. But here the bulky group are opposite to each other, so that's an anti-staggered, and here the bulky groups are at 60 degrees, so that's a Gaussian staggered conformer. So this is a Gaussian staggered, that means this is R. Acha. So that means none of the option is correct in that ways. Acha, this is Gaussian staggered, and this is anti-staggered is not written. Gaussian staggered is written. So this is definitely Gaussian staggered. So D is definitely R. So D is definitely R, and C is S. C is S. Yes, technically it should be written anti-staggered, but sir, if it is written like this, still I can definitely. Gaussian is also a staggered form when torsional angle is when theta is 60 degree, and when theta is 180 degree, that means bulky groups are directly opposite. That's anti-staggered. It has written staggered and Gaussian. So obviously staggered will become anti-staggered, and Gaussian is definitely Gaussian staggered. Sir, let us revise the potential energy of them, sir. So again, revising the potential energy. So if we just see their energy profiling, who has highest energy, sir? Eclipsed form. That too fully eclipsed will have highest energy, followed by partially eclipsed, followed by Sir, Gaussian staggered will have more repulsion, sir. Repulsion between what? Repulsion between the bulky groups. So then you have Gaussian staggered, and most stable will be anti-staggered. Sir, sometimes Gaussian staggered can, generally beta, this is the set of potential energy order between them. So generally, anti-staggered is most stable and fully eclipsed is least stable because energy of fully eclipsed is highest. Sir, sometimes once you have intramolecular hydrogen bonding, then in those cases Gaussian staggered becomes more stable. So a very famous idea, but yes, this clearly revises what for us, sir, conformational isomer. Moving forward, my answer is correct, but you change the options. Aspirant beta, are we getting any marks from this? No, sir. We will definitely guess marks from this, sir, but on the D day, sir. Here we are just learning, sir. That too with a calm mind, sir. So, first of all, the first question has my bad because that's a typo error of the structure. But I hope everybody is clear, and I hope we have completely revised conformational isomer with just one question. So, obviously, answer for this one will be option 1. Let's hope we will have less of typo errors after this. So Archana, Chinmay, perfect beta. Now moving to the next one. Sir, again a question to revise conformational isomer. So let's hope everything is good with this question, and let's hope everybody can extract best out of this one. So quickly start the next one, beta. Draw the structures using your pen and copy, everybody. Draw the structures using pen and copy, everybody. Chalo. I hope everybody is doing it. So this is the first structure. Okay, so here the conformational isomer are given in Newman projection. Again, Newman projection. So revising questions again, projections again, and then you have to give their name. So that means, sir, we have to just predict what are these compounds. So actually this will help also because the previous structure was not beautiful. So let us again draw it. So this is my front carbon. So this is your front carbon having two hydrogens and one methyl group. Because I just have to draw the structure so that I can just name it. So simply drawing them. So this is my back carbon. So this is my back carbon having what, sir? Having one methyl, one hydrogen. So one hydrogen and one ethyl group, because this is also a carbon. So CH2, CH3, that means ethyl. So let me rather draw this methyl here because it will save some space also for me. So methyl as an Me here, but it is having ethyl as in CH2, CH3. Let us name this compound. So, sir, this is a branch 1, 2, 3. This is a branch 1, 2, 3. So you number it from anywhere. So this is 1, 2, 3, 4, and 5. So third carbon is having a methyl. That means this is 3-methyl pentane. That means this is 3-methyl pentane. Okay, sir. That means A is definitely P. So A is P. You're gone. You're gone. Now, so talking of B, so this is now, let us, I guess everybody get it. So let us draw it simply. So this is front carbon. So C having two hydrogens and one methyl. So two hydrogens and one methyl. So this is my back carbon. So this is a back carbon having methyl, hydrogen and hydrogen. So two hydrogens and one methyl. So, sir, this is simply 4-carbon straight chain. That means that's butane, normal butane. So B is Q, although you do not even have to check if options are there. Now you just check C. So checking for C. So this is the front carbon. So front carbon, it is having one hydrogen, leave it, it is having one methyl group. So one methyl group and one hydrogen. Okay, sir. What about the back carbon? Sir, this is my back carbon. So connected with the back carbon, that back carbon is having two hydrogens. So these are your two hydrogens. But sir, the back carbon is then connected with this one carbon, two carbon, three carbon, and then that third carbon is also connected with the front carbon. So that's a cyclic structure, sir. So the back and front carbon are connected with three carbons. So that means, sir, 1 2 and then again three carbons. So carbon number 1, carbon number 2, carbon number 3, and they are connected, sir. That means this is a cyclopentane with a methyl branch. So that's a cyclopentane with a methyl branch. So sir, that's a cyclopentane with a methyl branch, sir. That means, sir, cyclic structures, the C bond C, all the C bond C of the cyclic structures, they can also are single bonded, so they can also rotate, sir. Yes, technically we draw only conformers of cyclohexane because our cyclohexane is free from any type of angle strain, and hence its conformers are easily and comfortably seen in mother nature, and they have some specific properties also. We'll do some questions of cyclohexane conformers also. But yes, technically cyclopentane also, cycloheptane also, they also have, because C bond C exists, so C bond C will always allow the carbon to have free rotation. So their conformers also exist in nature, although not very much asked. Because sir, these rings have bare strain, because as a carbon tetrahedral system, I want to remain at an angle of 109 degree 28 minute. But if you are forcing that carbon to form a cyclic ring, then the bond angle get reduced from 109 degree 28 minutes. So these cyclic structures want to open up themselves. That's why once we say degree of unsaturation of alkene is 1, that means it has two hydrogens less, and hence it is more reactive than alkane. Similarly, cycloalkenes are also more reactive than alkane because they want to open up. Who do not want to open up and as clearly as stable as alkanes? Sir, cyclohexane. Because once we have experimentally seen, a scientist named Bayer has even said experimentally and theoretically that cyclohexane is free from any type of strain, and also it is technically said that cyclohexane has zero Bayer's strain, है ना? But sir, it is cyclopentane. Yes, beta, it is cyclopentane. So few of the conformers of such cyclopentane, you have seen the invitation of a marriage. Sir, that envelope is actually a type of conformer. Sir, this. Sir, if you just close this envelope, these are the conformers of cyclopentane also that exist in nature. Not very famous. Cyclopropane is highest Baird strain. So it is, the carbons are having no conformers. It is just a planar species. But the butane also has conformer. You have seen a Rafale aircraft, no? So this is a conformer of cyclobutane. So technically, sir, free rotation can exist between C bond C, sir. The only thing is, because I'm strained, so my conformer are not very famous in the in the stables of JEE. But actually, if I'm C bond C, then I can freely rotate. Now, sir, we got this also. That means this is one methyl cyclopentane. So methyl cyclopentane has an R. That means C is R, C is S. So this is also gone. So you have definitely got your answer. And that's why I said beta 50%. Great, Krupa, Archana. Yes. So that's why I said, let us be easy. Let us attempt more and more questions and try to learn within the session only. And hence, let us take time here. Because if we finish fast, I will give some homework questions. Ultimately, you have to do those questions by yourself. So do them here only, and let us have a thorough discussion around it. I hope everybody is enjoying it. So let us move forward. Sir, इतना इंग्लिश मुझे नहीं आता, प्लीज स्पीक इन हिंदी। सुजिता कुमारी, कुमारी जी, just read the name of the channel, beta. It is PWJ English, and the reason a separate channel has been established, because beta, there are many students in India who are not comfortable in Hindi language, and that's why this separate funnel is established by obviously PW, and hence beta, I am sorry, I can only communicate in English. Chalo, I hope everybody is good. Sir, this lecture will be only for questions practice. Nahi Archana, we'll be practicing questions and we'll be completing the complete optical isomerism, but with question practice, because what I generally do in a class, we solve concept, sir, we discuss concept and we solve few questions. So here I'm not just solving few questions, I'm solving many questions, so that too with proper discussion. So that's why I have taken this special Sunday class, because it will be extended. So we'll be discussing theory also, obviously, and we'll be discussing questions also. The few questions, the initial questions I'm having, so that you can, because last class I've done a poll na, and most of you said no, that you have not attempted homework questions, and 70% of you said yes, that's sir, we have attempted those questions which you made us attempt in the class. But obviously, because we have to start alkyl halides, and I guess we are in the 7th lecture of alkyl halides and not have started alkyl halides, so that's why in order to wrap isomerism I have done this separate session. I hope so it will be helpful for my syllabus for my Lux JEE students also, and definitely because sir, it's a practice session, so that, and involving the stereo-isomerism, which is very much loved by mains and advanced, actually advanced. So that's why I have made this class live in YT as well. Chalo, let's move forward with practice of some more questions. Sir, you were definitely discussing about conformational isomer, and you said cyclohexane conformers are easily seen. So let us practice this question also, which will help us to revise conformational isomer. Giving you again 1 minute. So everybody please read. Everybody please read. Chalo. Quick, everybody. Sujit. Sujita. Sir, the right answer is B. Great, Sujita. See, now you are doing it. You said that you don't know, but beta, if anybody can try, anybody can do everything. The only thing you have to try. Chalo. What if anything can be said about the magnitude of equilibrium constant K? So let's say this is an equilibrium and has a equilibrium constant K. So the equilibrium constant can always be written as K. Let's say K is equilibrium constant. It is concentration of product upon concentration of reactant. Here product is also 1 stoichiometrically. So this is 1, 1. Sir, this is the most famous conformer of cyclohexane is a chair form. The chair form is most stable. So because I have two chair forms, so let us make that chair form again for you. How to draw a chair form? Beta, draw two parallel lines, approximately parallel lines. Then a top carbon, join this with both the lines. A bottom carbon, join with both the lines, and there you go. You have beautifully formed your chair form, which is the most stable, generally the most stable form of, yes, again, if you have intramolecular hydrogen bonding, then the boat and twisted boat form can also become stable because of intramolecular hydrogen bonding. But generally, chair isomer, this is a chair isomer of a cyclohexane, which is more stable. Now, sir, this chair form also has some van der Waal and torsional strain. How? Because it has two types of bonds. One is axial, one is equatorial. So how to draw those axial and equatorial bonds? Sir, we just stand on these carbons and do top, bottom, up, down, up, down. So standing on this top carbon and drawing a top, up, down, up, down, up, down. So that means these pink lines are my axial bonds. These pink lines are my axial bonds. Sometimes these axial bonds are above the ring, above the plane of cyclohexane. Sometimes it is below the plane of cyclohexane, but ultimately they are axial bonds. Sir, how to draw an equatorial bond? Because the next bond is for the equatorial bond for them. So you do not have to worry. Just think of a perpendicular x-axis from that axial bond. Because this is up and because each carbon is tetrahedral in two bonds, the green lines are on the same plane. That means one will be up above the plane, one will be below the plane. So how you should draw your axial, sir, these are my axial bonds. How you draw your equatorial bonds? Sir, just below the plane a line not parallel to x-axis. So here also think about that x-axis. So just below the plane, because this is up, so below the plane. Sir, because this is also up, so below the plane. Sir, because this is down, so above the plane. Sir, because this is down, so above the plane. Sir, because this is down, so above the plane. So that means these are your equatorial bonds. So technically each carbon has an axial bond and an equatorial bond. Now, sir, energy profiling was done for these cyclohexane conformers also. Okay. And energy profiling told us that whenever you have bulky groups, then try to keep those bulky groups in the equatorial position. Why? Because they were having less repulsions. Because as you introduce them in axial positions, sir, axial position, let's say I have this axial position, for example here, you have, this is your axial position, and in this axial position you have a bulky isopropyl group. Here you have this methyl group in the axial position. So sir, axial position will have more torsional bond pair repulsions and van der Waals repulsion also. Sir, but we have nothing over here, beta, down, up, down. Even you have hydrogen. So with this hydrogen also, with this flagpole hydrogen also, they will have repulsion. Rather, at equatorial position, the repulsion is less. Sir, but ultimately this is also having one methyl group and axial position. This is also having one methyl group in axial position. But technically you said more groups on equatorial position as an E position provide less repulsion. So repulsion is less. That means more stable. So you tell me here bulky group is present in axial position. Here bulky group is present not in axial position but rather in equatorial position. So you tell me equatorial, because ultimately one methyl group you are having in axial position, so that is tied. Now you try to put them in equatorial position. So here this is an equatorial position, here this is an equatorial position. So ultimately only one methyl group is coming in equatorial position. That means number of equatorial positions are tied. Now because number of equatorial position are tied for these alkyl groups, so rather I will try to put the bulky alkyl group in the equatorial position. So here bulky alkyl group is in the equatorial position, so this side of your compound will be relatively happy. It will have some repulsion, but it will be happy with respect to whom? Sir, here bulky group is coming in the axial position, sir, so this is not happy. So spontaneously, will this reaction proceed in forward direction? No, sir. So spontaneously, this will not try to stay in that conformer because that is having high energy, less stability. So what can you say about your value of K? Sir, value of K will be less, sir, because this equilibrium will have more percentage, more concentration of the reactant side, because reactant is more stable. So if concentration of reactant is more, then obviously value of K is less. So value of K will be less than 1, which is definitely shown by option 2. A beautiful question to have a revision of of yes. So great, Ashlesh, Sanjana, Krupa. Great, beta. Great. I hope everybody understood it. So that means the correct. So I hope everybody understood it. Sujita, B is right. Yes, perfect, beta. Perfect, Sujita, Ranga, Ramakrishna, everybody. Great, beta. Chalo. Moving to some revision of geometrical isomers. Sir, then we'll be, sir, you are revising everything? Yes. So that's why extended class. So quickly, revision of some geometrical isomers, quickly. A revision of some geometrical isomerism questions, quickly. A revision of some questions of geometrical isomerism, quickly. Sir, if two compounds have same molecular formula, same structural formula, but different three-dimensional orientations. And why? Because of a restricted center. Then those isomers are geometrical isomers. I hope at least you have written the question. I hope at least you have written the question. I mean, drawn the structures. Let us explore them together. Now, sir, the question is saying which will not show geometrical isomerism. Sir, geometrical isomerism you said arises due to restricted rotation, and restricted rotation are, sir, double bonded system and cyclic chain, because sir, now we have seen cyclic chain also will have one bond up above the ring, one bond below the ring. So cyclic structures are also capable because they also have restricted rotation, because you cannot break the complete cycle. So sir, okay, now moving to option 3 directly, sir, you said cyclic system is also a geometrical stereocenter. Yes. So if it is having methyl group, then definitely, sir, if you are saying that this is your cyclopentane and one bond will be up, one bond will be down. So just drawing up down scenario. So methyl can be on the top. So this is a cis form. And sir, this can also have one more isomer where methyl may be opposite, so this will be a transform. So that means that because it can show geometrical isomer, so it's not an answer for us. Now all the other cycloalkanes are having double bonded carbon within themselves. Sir, double bonded carbon is a stereocenter, agreed. But double bonded carbon in a cycle, sir, cyclohexanes have each carbon tetrahedral. So because of that tetrahedral carbon, if my two bonds are belonging to the cycle, which will be there in the plane of the cycle, then one bond will be up, one bond will be down. Hence, cycloalkanes are geometrical stereocenter. But sir, if I am a cycloalkane also and I am having double bond also, then both of my bonds will be in the same plane, because now these carbons are not tetrahedral. So now these carbons are trigonal planar. So these bonds, these CH3 and H can't be up and down. They will be there in the same plane as the plane of the cycloalkane. So that means now this ring will not act as a geometrical stereocenter because it has no up and down because of these carbons. Obviously, because of this carbon, this will be up, down, this can be up, down. So OH and H can be up, down. So I'm just drawing this as what, again, as a system like we have drawn over here. So that means that this is again a cyclopentane, but these carbons, sir, can't have up down thing. Obviously, these two carbons can have this up down scenario because they are still tetrahedral. Now, sir, you have a stereo center, sir. You have a stereo center because of these carbons. But sir, then groups should also be different because it is having CH3 on both the sides and OH and H on one side, then if even if you change H and OH, because this side is same, so although you have a restricted rotation, but sir, does only having geometrical stereo center make us geometrically active? No, the groups attached on both the ends must also be different. If they are different, then only you will see different orientation in three-dimensional space na. If groups are same, then even if you have a geometrical stereo center, but the compound can't have different orientation, so this can't show geometrical isomerism. But sir, this double bond can. Beta, how can this? See, if this is on the same plane H, this is on the same plane CH3. So this H can't feel any difference, this CH3 can't feel any difference, because these are just on the same plane. So that means this will not show no GI, and because no GI, hence an answer. Talking about this, sir, this is the same thing, sir. It is having two hydrogens, sir. So these carbons can show up, top and down, but because two groups are same, sir, so how can you see CH3 is opposite or CH3 is same as H? So this becomes geometrically inactive. What about this, sir? Same scenario, they can't be up down, sir, they can just be in the same plane, so no possibility for them. And sir, if we just check for this, then the environment, how can you draw? The environment says that these chlorine and these CH3 are on the same plane, they can't be up and down. And for an alkene also, you can draw this Cl and CH3. So this alkene is also geometrically active, but beta, it should have a group, no? It should have a different group, no, because it is a connected chain, so they have same environment. Rather, if they have some A or B, then you can say A is opposite to CH3, then A can be same side as CH3. But these carbons have same environment, hence you cannot mark that difference. So this will also be, not showing any geometrical isomerism. So I am sorry, I guess I have given an option which says single correct. So obviously this is a multiple correct question. Now, talking about this, sir, come on, sir. Obviously, these are on the same plane. So because they are on the same plane, so they can't have different orientations. And sir, this OH is just one, sir. If you just draw this OH, who will it be seeing the difference with? Because there are no other people with which this can feel that I'm on the same side or on the different side. So definitely here also no GI, here also no GI. That means only this is showing geometrical isomerism. So your answer will be 1, 2, 4. Now, obviously, I can't, but still, let's say C. Why? Because that is odd one out. 44%. So great. I hope you also thought the same thing, but I hope now everybody's clear. Now, I have one point for you. So that means if cycloalkane is having a double bond, that means it has become a cycloalkene. Then sir, cycloalkene will not show GI. Sir, all cycloalkenes can't show GI. No, they can. When? So that's a point, but yes, that's not for a mains level the question, but yes, let me just give you an idea because we are discussing things in detail. So just giving you a note. What is that note? Generally, cycloalkenes, beta, not alkanes, cycloalkenes are geometrically inactive. We have already seen this with examples. But if I have 1, 2, rather let me draw that thing like this. Yes, I hope now everybody is predicting what I'm drawing. Sir, you are drawing 8-member. Sir, you are drawing 8-member cycloalkane because carbon's ring having 7-member carbon having 7-member carbon ring, sir, they can come in a plane, sir. But cyclooctane, but eight members carbon ring, which is cyclooctane, is actually, sir, non-planar. It is always non-planar. Even if you give cyclooctane a aromatic stability, still, because the carbon members are large in number, so the family is very huge, the family cannot come in a plane even if you provide them extra stability of aromatic nature. Sir, this is always non-planar, sir. It is actually a tub shaped molecule. So cycloalkanes having 7 members or less, they can come in a plane if you provide them some extra aromatic stability. But even if you provide extra aromatic stability, cyclooctane can't even come in a plane. Now, if I have the cyclooctane and if I introduce a double bond anywhere, because obviously wherever you will draw that double bond, it will be just this one too. Okay, let me not make it over here. Let me just take this picture, because this detail I have again make you revise for cyclooctane. So now drawing it separately. So let's say this is my whatever this is now my cyclooctane. This can definitely show cis-trans isomerism. Cis-trans can be shown. Just write this, beta. Just write this, sir, because these isomers have been isolated, because its geometrical isomers have been isolated in mother nature. Sir, how the cis form will look like? Beta, cis form will simply look like this. 1, 2, 3, 4, 5, 6, 7 and 8. Just look at this geometrical form. This is a cis form, sir, similar groups on same side. So this is a cis form. Can I draw its transform? Yes, definitely I can draw its transform, because technically it was not, the carbons were not in a plane, but because of this restricted rotation, the carbon will come in a plane. So this will make the cyclooctane a planar molecule. But who is making it planar with respect to carbon? Who is making it planar? So this C double bond C. Yes, I am very much sure about these CH2. They will lie in the same plane as these carbon. Some conformational isomerism you can see among these green carbons, agreed. But if it is a double bond, then this will remain here only if it is made here by mother nature. So this will always have a cis configuration, similar groups on same side with respect to these two carbons. Yes, these 4 green carbons can have some different plane. Can have, because they can freely rotate. This can't freely rotate because it has been restricted by the spy cloud. Now, sir, how you draw the transform? Beta, just 1 carbon, 2 carbon, 3 carbon, 4 carbon here. So 1 carbon, 2 carbon, 3 carbon, 4 carbon here. Let's say this is connected. Obviously that will be connected from back side or front, but I'm just showing that this is connected. Now, sir, where you are supposed to draw that, beta, draw that pi bond anywhere. Let's say I'm drawing that pi bond here. So now rotation is restricted, sir. So if you are there, then you will always be here. You will always be opposite, because now rotation has been restricted. So yes, technically cycloalkenes can't show geometrical isomerism, but if your carbon chain is of 8 members or more, then those cycloalkenes can show GI like this, because they have been isolated, they have been seen in mother nature, and hence a good one. But yes, obviously not for this is a good one. So star, you can miss it if you are just revising for mains. है ना? Anyone know class time? अरे यार, Krupa. I don't know. Krupa, why class timing, beta? See, you want me to skip GOC? Then I can definitely do beta. And I know you do not want, but yes, as a student, we do this. Sir, array, sir. First of all, if we are not starting, we want everything to start. And once it has started, array, or so make it short, no. So actually, beta, time can only beat time. So we have to invest time because obviously I can just anyone cloak. Krupa is, so I hope Krupa you're good. Let us practice questions na beta with utmost level of ease discussion. है ना? चलो. Akhilesh is saying, okay. Yes, Akhilesh, I definitely agree with you, beta. Sir, यार कुछ समझ ना आ रहा. So Akhilesh, please try to be more focused over here. Then obviously you will try to extract something out of it. है ना? चलो, moving forward, shall we? Sir, till 2, please. Adesh, don't restrict. Are 2. Come on. No, not at all. We'll extend this class for at least till we finish this beta. So at least 3 hours. I said 3, 3.5, maybe 4. है ना? चलो, let's move forward. Sir, another question. Time starts now. Quick, everybody. Quick, everybody. Quick, everyone. Now this will be an easy one, beta. Species which will show geometrical isomerism. नहीं, निष्केश नीट के बच्चों को एडवांस के क्वेश्चन सॉल्व करने चाहिए. नॉट necessarily, but yes, beta, because the paper we have seen this year, so actually it will just give you confidence. So if a student is doing well, then obviously he should explore more, because exploration is the definition, is one more definition of science. है ना? चलो. So let's solve this one. So species which will exhibit geometrical isomerism among the following. Which will exhibit geometrical isomerism. So sir, this is having a restricted rotation. Yes, but sir, it is connected with ring. Okay, but the ring is also, sir, ring is also having pi cloud. So this D cannot be up down. This T cannot be up down. That means it will be in the same plane. Okay, sir. So technically this whole thing has become a restricted rotation now. So if this H and this T, so this is also on the same plane, this is also on the same plane. So you can, because everybody is having a restricted rotation, so let us consider the complete molecule is existing in a plane, because actually it is. So the complete molecule is existing in a plane. So the complete molecule is in a plane. So that means the complete molecule is having obviously tetrahedrally, but obviously trigonal planar point, but everybody is in a plane. So if H and T are on same side, sir, H and T can be opposite also. So this can now definitely show geometrical isomerism, although having cycloalkene, because all the carbons are cycloalkene, so complete system has turned into. So that's why in the previous slide also, where I've given note, I've said generally, but here because a scenario has taken place where this pi cloud has made complete carbon restricted in a single plane, so complete carbon has become planar and their bonds are also in the same plane. I'm not up down, so I am fixed here, because even this T, which is tritium, a heavy isotope, a radioactive isotope of hydrogen. This is deuterium, not radioactive but heavy isotope of hydrogen. So this H and this T can be on same side. Sir, you can have different orientation also, but obviously of a different compound, and that different compound will be a geometrical isomer. Sir, good one, sir, good one. Now, acha, again I have given wrong option because I guess you will have more options here. But still, I hope you can. We are just learning, sir. We are not here to get numbers. Who will give number? We are just learning here, sir. So wrong poll, sir. It is okay, sir. Now, what about this, sir? This is having a restricted rotation, sir. But these two bonds are same, sir, because one carbon, two carbon, and double bond. One carbon, two carbon, and double bond. So these are same group, sir. So how can you say, sir, same side or different side? So this will not show GI. Answer. The nitrogen will be having lone pair. So OH or H can be on same side. Sir, OH on H can be on opposite side. These are oximes. Again, a different example of a geometrical stereocenter. So this can also show GI. Sir, this is NH2 bond NH2. So let us make it symmetric. So NH double bond NH. Array, sir, this is diazo group, sir. So why you have drawn like this, sir? Because beta nitrogen will have lone pair. Sir, if it is cis, you can also draw trans. Generally, it is syn or nt. Also, the nomenclature point of view. So, sir, this can also show geometrical isomerism. I'm sorry. So 1, 2, 3. So let us make 2 is not an answer. So obviously this is a multiple correct, but because 2 is odd one out, so I'm just marking 2. Chalo, I hope. I mean, seeing the percentage is not optimum because that was also multiple correct. Yes, Krupa, great. Pick out the odd one out. Yeah, see, my students know. So great, Ashlesh. My students know. Pick odd one out. Great. Chalo. Yes, Naresh, great beta. Naresh Kumar Bhaskaran, B. I hope you also picked odd one out, Naresh. Great beta. Chalo. Moving forward, sir. Next one. Now see beta, these are JEE mains question. Now invest. Now be very sincere. Because now this will be halwa. I'm giving less time also. Sir, why we study in detail in a class? Because mains should be halwa for us. Yes, for advanced we will think one step, sir, because advanced we have time, sir. Advanced ask only 17, 18 questions, sir. So 17, 18 question 1 hour, sir, yeah? Come on. Everybody. Come on, everybody. Come on. Which of the following will show geometrical isomerism? Will show geometry. So, sir, this is C with an H with a Br, sir, double bonded. So these groups are different, sir. But sir, this definitely is a carbon. But sir, it is having C same, sir. C same, sir. Then it is again meeting here. So definitely this carbon, whatever group it is having, it is same. So how can you say same side or opposite side? Therefore, it can't show GI. Sir, again here these two hydrogens are same, sir. So you in a restricted rotation has two different centers, two different stereo centers. Geometrical center has two different stereo centers, exactly the centers. So one pi cloud is a geometrical stereo center, but the two centers it has are two different carbons. So both the stereo centers of carbon should be differently substituted, sir. I hope you are getting that idea, and hence it is because this one is differently substituted, but now that one is not differently substituted. So no isomer. Here both are, because this is also H and CH is H and Br, so different. And if you are having this carbon, so this is 1, this is 2, so this is CH2 on this side, but this is not CH, this is CHBr. So these two are different, and because they are different, so sir, different there also, different here also, this you can definitely show geometrical isomerism, because if you just draw them, Br and Br will be close, Br and Br can be distant also, so this can definitely show GI. Sir, here this is same, so not an answer. Now this is a easy one. Obviously mains should be easy if you are practicing well. Percentage is less beta, but I hope everybody got it. Now you can ask a doubt here. Yes, Sri Krishna, great. I hope everybody is good. Chalo, great, perfect. Moving to the next one. Now I guess, chalo, this is also multiple correct beta, so giving 1 minute. Although this is a JEE mains question, but yes, we have played with the question, just twisted it, a bit, so multiple correct. So please do it properly. So this one is also a multiple correct. This one is also multiple correct. So play accordingly. Sir, obviously this is same, sir. So geometrically inactive. Sir, this is same, sir. This is different, sir. So this is good, sir, because different. But this carbon is having same environment. So gone, sir. Next, what about this? Sir, this is good, sir. Different. And sir, one carbon CH2. Here CH2 same, but this is CH2. This is different, sir. So this is also good, sir. Same, different. So you can have different three-dimensional orientation. So this is your one of your answer. Sir, this is also different. And talking about this, so this carbon same, this carbon again methyl, this carbon again methyl, and point. So this is not no GI. This is no GI. Because of this, you have no GI. But sir, this is a cyclo. So this geometrical stereo center failed to give geometrical isomerism. But sir, this one will, this geometrical stereo center, because our cyclic chain is also a geometrical stereo center, and this is having CH3. So CH3 can be, let's say this is up, so it can have a down bond also. Let's say it is up, so it can have a down bond also. Sir, this can show geometrical isomerism, sir. Methyl methyl up or methyl methyl opposite. So this guy failed, but this is geometrically active because of this cyclohexane ring. So hence this can show GI. So definitely this is also your answer. Good one. Yes, obviously this was not a case with the mains question. I just twisted it. Great. Percentage is good. Now I hope everybody is gradually catching up. So moving to the next one. Again a mains question. Giving 45 seconds because single correct. Quick. So which of the following compound will exhibit geometrical isomerism? Arey, come on, sir. We can do it. Let me just watch the comment section for some doubts. Yes, Sahil Hassan, great. Great, everybody. Great. Everybody is doing great. Good afternoon, music ethic. Good afternoon, beta. Good afternoon. Good afternoon. Great afternoon. Chalo. Sir, which of the following compound will exhibit geometrical isomerism? Okay, beta, let us draw it. So, sir, butene as in butanene. So, sir, this is butanene. Okay, beta. Now, second carbon is having phenyl. But, sir, this is CH2, so same. So, no GI, sir. Sir, this is propane. Okay. Sir, it is having 1, 1. Array, come on, sir. You do not have to draw it because phenyl, obviously planar. So, propane, no restricted rotation. So, go away. Now this is again butene. This is again butene. Okay, this is 2 butene. Then 1 phenyl. Ha, sir. This carbon, the one stereo center is having H also and methyl also. So this is different. So good. 1 H and 1 this. So this is good. Okay, sir. So this can show GI, sir. Answer, sir. Because we have answers, so obviously option 3. 48%. No, this is not good. So I hope everybody is good now. Any doubt? I'm holding for a minute for some doubts. So everybody hit me whatever doubts you have till here, because we have not even started optical isomerism. Some students were asking, sir, it will only be a question class. No, beta, because we'll be dealing with optical isomerism also. All the good details with optical isomerism. But yes, before dealing with optical isomerism, let us revise the other isomers that we are doing, but we are revising with optimum questions. Any doubt? Else I want confirmation, beta. Whoever, thank you. So my YouTube students are giving confirmations. Lux Warriors, what happened? Whoever is there, whoever has not gone for a lunch break, let's move on fast. Music, beta, we have many students with us music, so let us be compassionate. That's why I've chosen a Sunday class, so that we can relax and we can enjoy the class. Chalo. So, Ashlesh, thank you. Sanjana, thank you. That is what I want from you people, beta, because without interaction, master is dead. Master is dead. Master is nothing beta without so bacha log has to be present, no? If you go out to eat roti your lunch, then master drinking black coffee. Chalo, moving forward quickly. Last question, then we'll move to optical isomerism. Last question, then we move to optical isomerism. Easy one, very easy one. So 30 seconds, and I want students joined in YT also. Ask, hit the comment section with your answer. Music ethic. We will not lunch killing appetite with coffee beta. Don't worry, we will not take break. Yes, bio break if required, we'll take. Sir, why butanoic acid is more acidic than propanoic acid? See beta, technically this acidic nature, no, for carboxylic acids, for organic acids also, the acidic nature is predicted by the value of dissociation constant Ka. So practically that's an experimental science. But yes, scientists have done those experiments, and GOC with electron displacement effect has helped. Sir, if you want to make a carboxylic acid a strong acid, then you have to stabilize the conjugate base, because ultimately if you compare these organic acids with mineral acid, they are weak acids. So sir, organic acids can, how they can become relatively strong? If you stabilize their conjugate base. Sir, conjugate base is electron rich, carboxylate ion minus, so you just withdraw that minus. Hence it is generally said that electron withdrawing group increases acidic nature and electron donating group decreases acidic nature. Sir, because alkyl group, if you add more alkyl group, then sir, adding alkyl group is plus I effect, but sir, plus I effect is practically irrelevant, sir. Plus I effect is practically irrelevant if it is large distant. So propyl or butyl will obviously just go by basic, then you say butane apply relatively minutely more plus I, hence it should be electron donating more, so should be a weak acid. But yes, definitely sometimes the value of Ka, which some references gives creates a controversy. But yes, for a mains level question or for a question per se, the more is the alkyl group, obviously the weaker acid it will become because of the plus I of the alkyl groups. So butanoic acid should be slightly less acidic than propanoic acid. हाँ, है ना? If at all a comprehension or a reference or a experimental value is showing it is more, if it is showing it is more, then obviously that will become a factual science, which is obviously a part of chemistry beta, है ना? चलो, sir, let us solve this one quickly. Arey sir, come on. First you name it, sir. So here you have alkene, so 1, 2. Here you have alkyne, so 1, 2. Multiple bonds are given same preference. But sir, this is also having more branch over there. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, as in 6 carbon, with second carbon having bromine. So 2 bromo. So these two are gone. 2 bromo, then you have hex, but 2 ene, 4 ine. Yes, so obviously with name only, this is your correct option. But why this 2e? As in the second and third carbon is the 2e. This is E as in, if this is my C double bond C, it is having 1 methyl, 1 bromine. It is having bromine here, so this is here, so another bond will be this, so this is H, and this is some carbon chain. Now let us do the sequence rule. What is sequence rule? Nothing beta, just compare the mass number of the directly attached atom. So who is heavy in this carbon? Bromine or methyls are bromine and have heavy, so this is senior. Heavy as in the nucleus. So which is heavy? Obviously this is carbon, this is H, so this is heavy, so this is senior. So senior group opposite. What is the rhyme that we have? Senior group opposite. So this is your E form, and hence 2E. Although even if you do not know 2E for this particular question, I guess this is done. So D is your answer, beta. Wrong. Students who have done otherwise, I hope everybody is good. Sir, is NCRT line by line read need for? Nahi, beta. Student P, no for NCRT line by line, beta. Technically, na, NCRT is not a good book to read to learn from. NCRT is definitely a good book to revise. That, for example, if you want to revise, then it is a good book to revise, because sir, your notes will have more things, and if you just want to cut out extra things and just want to revise the relevant things, if you're having short of time, then read NCRT. Else, technically, as a student, as a JEE aspirant, for inorganic you may say, but for organic and physical, beta, obviously you have to walk an extra mile, so invest yourself in the class notes, है ना? Music ethic is saying, sir, today only I completed GOC. Okay, beta, great. So it will be helping you, music ethic. Chalo. Now, sir, moving forward. Krupa is saying, will there be a break, sir? Beta, Krupa, let's see. If we require after 1 hour more, then we take just 10 minutes bio break. But else, let us be efficient and utilize this Sunday with best of our efficiencies. है ना? Chalo. Sir, can you explain 2E and 4E again? Yes, Lenka. Chalo, so let us do this again. Although we'll have more questions for EZ beta, so let me just quickly revise it from here only. Let us not quickly write it completely, because we'll be having more sequence in rule for optical isomers also. But yes, because you asked, so this is second carbon. So how you name this 2,3 double bond with the lowest number? So 2. So 2E, as in the second and third carbon, the lowest number is 2. So you have to decide the EZ configuration, the nomenclature for this type of geometrical isomers, because this is not having similar groups, so no cis trans. So another nomenclature is EZ, which requires CIP rule. Just focus on this carbon. Sir, having methyl and bromine. Directly attached atom is carbon and bromine. So which is heavy? Bromine. So bromine is senior for this side of carbon, this side of stereo center. This side of stereo center is H and directly C. Just you check the first atom. If the first atom ties, then go for tiebreaker, directly attached atom. So it is H, it is C, so obviously C is heavy, so this is senior. So senior group opposite is an E form. So senior group same side is a Z form. So 2 is E. Now obviously not why, sir, this is not double bonded carbon, sir, this is alkyne. So alkyne, sir, it is a linear molecule, sir. Obviously we just do nomenclature EZ for geometrical isomers, as in for double bonded carbons. Okay. So no 4E beta, just 2E, because 4,5 is a alkyne. It is not an alkene, so it can't be nomenclatured as EZ. Okay, Lenka? Good? Chalo. Starting with optical isomerism. What starting, sir? You have already told us. The basic you have already communicated. Sir, the only thing that we will now know, that if a compound is optically active, then this will definitely have a optical stereo center. And that optical stereo center, there are many optical stereo centers, sir, which can make compound capable of rotating the light in different directions. But that optical stereo center is an asymmetric center, having no element of symmetry. Sir, what is the famous example of that optical stereo center? So this is not the only optical stereo center, sir. This is our famous example. Why famous? Because our organic chemistry, the level of JEE for organic chemistry, utilizes 90% of the times a chiral carbon as its optical stereo center. There may be many more optical stereo centers, but the most famous optical stereo center for us is a chiral carbon. So most famous is a chiral carbon. Now, what is a chiral carbon? Sir, a sp3 hybridized carbon, as in which is forming 4 bonds. Obviously, it's a tetrahedral carbon, so you have a wedge dash projection also. You can have a Fisher projection also. This is how you draw Fisher projection, where this is your chiral carbon. Now, sir, it needs to have all 4 differently substituted bonds, and then only this carbon will be termed as a chiral carbon. Okay, sir, 1 point is done now. Sir, that means, can we just say that because this is having a tetrahedral system which is having no element of symmetry, none of the element of symmetry, that means, sir, if such chemical bonding can be applied to other system also, they can also become chiral. Yes, but let us, why complicate our theory? Why increase our theory? Let's say you have a center which is sp3 hybridized, that means tetrahedral, and have differently substituted system. So whenever you see such atoms, such central atoms, all those atoms can act as a optical stereo centers. Then sir, give us some example beta. As I said, we will read theory with questions now. So, acha, so optical isomerism we discussed. Optical isomerism we'll discuss. We'll see some more chiral carbons, but yes, because we discussed optical isomerism, so very, very rarely, but this thing also you should know theoretically. If I have a capability to rotate the plane of a polarized light, then the observed rotation, the value of theta depends on what? If I have more capability or less capability, whatever the hell polarimeter is giving me the value of theta, it can be positive plus 30 degree if it clockwise, minus 30 degree if it is anti-clockwise. But sir, what decides the degrees at this 30 degree? So the factors affecting optical rotation, a very theoretical topic, a very basic one also. Sir, wavelength of light source used. So if I have this light source with me, obviously this, generally the polarimeter that we have in our laboratory, that's a sodium lamp, also known as D-line lamp. The wavelength approximately, the sodium lamp, it will give electromagnetic radiation. Light is electromagnetic radiation, sir. So what is the approximate wavelength? Approximately it is 589 nanometers, a detail. Sir, the temperature, if you change the temperature, sir, obviously it will impact the value of theta. So what temperature we generally keep in our polarimeter? We keep room temperature, which is 25 degrees Celsius. If you change, theta will change. If you change wavelength, theta will change. Length of sample tube, because sir, this is ray optics. So if you have taken your organic compound in this vessel, in this cylinder, as you increase the length, that light will travel more, so the theta will proportionally change as per my ray optics. So it also depends upon the length of sample tube. And in fact, let's say my value of observed rotation is theta. Let's say theta is the angle by which I'm observing at the eyepiece. Here I'm observing an angle of theta. Polarimeter can easily experimentally technically these days, even if you go in your colleges in first year, you will again read chemistry, especially in your IITs and NITs. It is heavily government funded. So in first year also you have chemistry as in one of the semesters. So you do this polarimeter experiment. In my days they were, I mean, it was just giving a value of theta back in 2007 time of NIT Kurukshetra. R was analog, so we just have to read by that angle. So that, but these days you have digital polarimeter, so that value of theta can be easily seen. So if we change this length, then theta will change. How? Experimentally it has been seen. Experimentally it has been seen that the more you change the length, let me just, the more you change this length, which length? This length, the more becomes the value of theta. So that means this theta is directly proportional to the length of the tube. Generally, this length is measured in decimeter, because sir, obviously this is not a very long polarimeter, because the vessel is, the system is, so generally the unit in which you put this length is in decimeter. I hope everybody is clear. I hope everybody is clear now, sir. Then obviously it also depends upon the concentration of sample, because sir, if I am an optically active compound, the more concentration you take for me, so the more you have my concentration, the more I will rotate. So obviously this theta will depend upon the concentration of the organic compound which is present in the solution that you have kept in this cylindrical vessel. So the more will be the concentration. So the more will be the concentration, the more will be the optical rotation. I hope everybody get it. And generally the concentration term that you use, what unit you put this concentration term? Sir, in gram per cc or gram per ml. not moles. Generally, what questions we get over here, the concentration is mentioned in gram per ml or gram per cc. I hope everybody is clear. Now, sir, both are proportional. Yes. So, sir, we can do, sir, as we do in how we have got PV equal to nRT, sir, separately done experiment and then combine them. Therefore, on combining, I can say this theta is proportional to LC. And definitely you get a proportionality constant. So this theta will be equal to, the proportionality constant becomes alpha into L into C. Therefore, I'm just writing this formula in the next slide. Therefore, this alpha is equal to theta. This alpha is equal to theta upon length into C. Sir, C is my concentration already written, gram per cc. So this is in decimeter cube, and this is your alpha, and this alpha is termed as specific rotation. This theta is termed as optical or observed rotation. So this theta you actually see in your polarimeter, which is the observed value. Observed value is also called optical rotation. But alpha is a proportionality constant, which is called the specific rotation. Obviously, if how you define specific rotation, if L is 1 decimeter and C is 1 gram per cc, therefore alpha is nothing but theta. So technically how you define this alpha, specific rotation. So specific rotation is the observed rotation of the optical rotation of a compound if the length of polarimeter cylinder in which the concentration in which the optically active solution is taken is 1 decimeter and the concentration of optical active solution is 1 gram per cc. So that's just a theoretical idea regarding the experimental polarimeter. Sir, why? Because very rarely you see such questions. Very, very, very rarely, but still. A basic one, so please attempt beta. Very rarely you see such questions, but yes, it just gave a confidence that we know everything. So just do this beta. Music ethic. Beta, tautomerism. Tautomerism we definitely discuss, but yes, even beta tautomerism should be best discussed once you start mechanisms also, because tautomerism is a good topic as in 30 minutes will be required to discuss mostly everything about tautomerism, 30-40 minutes, but we will do a separate class for tautomerism, not this class. And here our topic is stereo-isomerism. So let us not mix things beta because as a science aspirant we should target things and deal accordingly, not random things. So ketone-all isomerism is a part of structural isomerism, but obviously we'll discuss it separately, not here beta. Sir, optical rotation is there, if there, when you will teach today. Sir, optical rotation is there, if there, when you teach today. Beta, I've already started. I guess you have just posted that before. So, sir, date of class. Beta, optical tautomerism I will discuss maybe. Actually, I wanted to start it with coordination isomer, with aldehyde ketones. But okay, let's do tautomerism also whenever we meet in the next session. So Laksh students, I told you tautomerism we'll do with aldehyde ketones. So we'll just put a Sunday class especially for tautomerism, because obviously in our class we have to start alkyl lights. So tautomerism we do separately, like in such sessions. So music ethic, whenever I'll teach tautomerism, I'll put topic name tautomerism also in YT so that you can also join. It will be in a Sunday only. On not next Sunday, but yes, definitely some near future within this Sunday or maybe the next one. Okay, chalo. I hope everybody has attempted this one. The question says a solution of glucose, an observed rotation of this. So this is your observed rotation. That means this is your value of theta. Decimeter, 2 decimeter tube length. That means this is your L. If concentration is 10 gram per 100 ml. So 100 ml is having 10 gram. So 1 ml will be having 10 upon 100 gram, because you need this concentration in gram per ml. So 100 ml is having 10 gram. So 1 ml will have 10 upon 100 gram. That means 1 by 10. Therefore, C is 1 by 10 gram per ml, or cc, because 1 ml is nothing but 1 cc. Now you have to calculate the specific rotation. Sir, we definitely know alpha is equal to theta upon L into C with the proper unit, which I have definitely converted. So theta is 13.2 degree upon length is 2 decimeter cube, 2 decimeter watt cube, I'm sorry. And this is 1 by 10, that means a 10 will come in the numerator. So this is 132 by 2. So 2, 6 is 12 and then 6. So this is nothing but 66 degree. I hope everybody has done this. Hey, beta, I hope things are clear. Guys, need a confirmation? Guys, need a confirmation. Oh, bhaiya. Chalo, I hope everybody is clear. Beta, pata hai, the electricity just got off. So everything works without electricity except one thing, which is air condition. So AC has stopped. So I'm sorry if I am perspiring. So why sorry? I'm perspiring, master is perspiring, and still you are asking timing. So Satvik, please be with me. Hai na? Chalo. Now, sir, coming to more questions. So beta, coming to more questions. What are these questions, sir? You said in order to have optical isomers, I need optical stereocenter. What is the famous optical stereocenter? A chiral carbon. But sir, you have more optical stereocenters which have just don't learn them, but let us do them by common sense. So we know chiral carbon is a center, sp3 hybridized system. Not saying carbon, sp3 hybridized system having differently substituted bonds. So if light gets to one, it is thrown, it is reflected in a way that plane gets rotated. So the questions, very important question for mains, because chiral carbon identification is a very important question for mains, because mains ask this. Leave advanced. Obviously, advanced love optical isomerism. Advanced is in love with optical isomerism. They mix all the organic question, and if they want to make it a good question, they add optical isomerism and stereoisomerism per se in it. But yes, mains also reciprocate. So let us learn optical isomers through questions with the identification of chiral center. So the first question is in front of you. This is a single correct, so you can give it a shot. Now, just draw the structures, beta. Just draw the structures. Great Krupa, great Sanjana, thank you. Because level and motivation of students are very important, beta. Keep me motivated by participation. And please, God, AC come. Please come. Chalo. Neha. Neha, are you the same my NEET warrior Neha from PW NEET channel? Hey beta, because I remember Neha when we were doing those NEET lives. Chalo, let's start. So sir, number of chiral center present in the following compounds. Sir, obviously this is CH2, so do not look at it. Yes, sir, this is C. Sir, having one methyl, one CH2, one O, and definitely one will be H. Sir. This guy is having one chiral carbon. Okay, so this is having one chiral carbon. Now, sir, this is CH3. Sir, this is C, one CH3, one CH2, one O, and one H. Yes, sir, this is also chiral, sir. This is CH2, sir, so don't look at it, sir, because if two groups are same, then how can I be chiral? Sir, but now, okay, sir, now that's why you have said, sir, oxygen is having 6 electrons, sir. If one gone, then a plus charge, sir. Sir, that means now it is having one lone pair. Okay. Sir, but that lone pair will be restricted in a plane, sir, will be having more repulsion, sir, and wherever lone pair is there, it will not allow the other bond pair to come. So that means although this is a pyramidal, this is trigonal pyramidal with respect to oxygen, but its geometry is tetrahedral, sir. That means it is also an asymmetric center. Let us see the group. Sir, lone pair is obviously different. Sir, one H, sir, one CH2 and one carbon which is differently substituted. That means that this oxygen also can act as an asymmetric center. Why? Don't learn it. We know carbon which is having four differently substituted bond receives light from one end and throw reflect proportionally so that plane gets rotated. Sir, the same asymmetry is arising here also, because geometry, yes, structure of oxygen is structure as in my position with respect to other nucleus. So structure is definitely trigonal pyramidal, but that lone pair will occupy a space in a volume in three-dimensional space where the other bond pair are never allowed to come. So I will also have no element of symmetry because I am also like a tetrahedral system. Hence, don't learn this. With your common sense only, you can say, sir, this is also a chiral center. I hope this is also a optically active stereo center. Yes. So let us know and learn theory with questions. So this is having how many chiral centers? 2. That means we know we can have analogy of that hybridization of chemical bonding, the VACPR of chemical bonding, and apply it with common sense of chirality, with asymmetry like that of a tetrahedral carbon. Now, sir, we know, sir. Come on. Beta, this is obviously optically active. Why? Because CH3, Cl, one group is C with a Br, one group is O. So this is chiral. So this is also chiral because two are bromine, fluorine, one is a C, one will be NH. So obviously this is also chiral. This will also have one H. This will also have one H. Sir, this is already optically active, sir. Why? Because lone pair, sir. So that will not allow. So one area lone pair, one H, one carbon which is CH3, one carbon which is Br. So obviously all bonds are differently substituted. So how many chiral centers you have? Sir, 3. So 1, 2 and 3. 1, 2 and 3 is option 2. 20%. I hope beta. I hope everybody is clear. 1, 2 and 3. Yes. Acha, okay. Neha is our NEET warrior only. Chalo, great Neha. Chalo. So Neha, what was your score, beta, in the NEET examination? Result has just came. Are you class 12th or dropper? Chalo. Moving to the next one. Again, exploring the same logic. So again, the same type of question, just to have a better understanding of the theory. Clear? Quick, beta. Try to respond and give an answer. $540 marks आए हैं, sir. Okay, great. What's your rank, Neha, then? Dropper now. Okay, great, Neha. Great. So, Neha, haven't you joined Yaqeen NEET in English? Or you are there also? Because I have not seen you there. So, you are just practicing by yourself. That is also good, beta. But yes. JEE 2027 के लिए कुछ नहीं पढ़ा. Beta, then पढ़ो. Then read MHTC aspirant. Then read, beta. JEE with officials. JEE with me officials. Chalo. You are giving answer to. Chalo. Start reading, beta. If you have realized that you have not worked, then start working, my friend. Now, chalo. Let's do this. Number of chiral centers. Sir, obviously you have told us you have a sulfur. Yes, definitely this pi cloud. Sir, this sulfur will be in conjugation with the pi cloud. Agreed. So this double bond may become single bond. But sir, ultimately, if you just look at this sulfur, that is a double bond. It may become a single bond because it has been delocalized. But ultimately, with respect to this sulfur, this is one of the nucleus positioned. This is one carbon position, sir, it is different. This is one benzene ring position different. And sir, now this lone pair will not allow those three bonds which are different. So that, sir, that means this is also clearly satisfying that O plus thing. So obviously this is one of the chiral center. Sir, obviously double bond, sir. I need sp3 hybridized carbon, sir. Sir. So HOH, sir, C with O, C. So this is also chiral, sir. This can't be because sp2, this is sp3. I mean, having same hydrogen, so two chiral carbons. I mean, two chiral centers, not carbon. Option Bombay. Chalo. Archana, good. I hope everybody is doing the questions as well. Moving to the next one. 45 seconds, quick. Now, aha, Neha, great. 40,458. So guys, 3 chairs for Neha. Because I have definitely seen her. She definitely has been a consistent question solver in our NEET English platform. And yes, the marks she has got is 540 and a rank of 40,548. So Neha, I mean, first of all, beta, congratulations. And second of all, you are not focused anywhere. You are not dwindling that, sir, I should take this college. You have not asked any question of that sort. That shows your confidence, that your conscience is just telling you that whatever counseling process will do, you can maximize your rank. And obviously because of that, you have already communicated that you have taken you have taken a drop. So that is a perfect sign of a great performer, beta. So God bless to you, and I hope you will be doing great with your career. Just keep on the good work, Neha. God bless. Sir, a carbon which has a sp2 hybridization need not be chiral, or if it is planar. Yes, beta. The primary condition we have of a asymmetric center is an sp3 hybridized system. So we need that sp3 hybridized system, but because that sp3 hybridized system has no sense of having an element of symmetry. If you have a planar system now, you just cut that molecule within that plane. What you will have above it, nothing. What you will have below it, nothing. So that means it is having a plane of symmetry. Sir, will you discuss those elements of symmetry? Very briefly I will discuss, and then we will explore it more with questions. And actually those element of symmetry slide that I'll be giving you will also be helping us with solid states. So yes, solid state is definitely only for advanced, because mains solid state has been removed. But yes, we'll be discussing the elements of symmetry that will help us in solid state for our solid state discussion. Then for organic, we'll be discussing questions on element of symmetry so that we can feel relatable with it. Sir, it has lone pair. No, that's why. Yes, Krupa, this the sulfur, I guess you are asking for question. Yes, it was having lone pair, same as that of oxygen. So having the same tetrahedral symmetry like you expect for a carbon. I hope everybody has done this one as well. So let's explore. Identify the number of carbon atoms in the following compound. Chiral atom, chiral carbons, okay. So, sir, everybody is CH2. Only this carbon I can see having CH3, having H. But, sir, this bond and this bond is same, sir. Because CH2, CH2, then I'll be meeting same. So, because two bonds are same, so no chiral center. Yes, sir. This will have chiral carbon, sir. Because this is methyl, one is CH2, one is H, and one is a carbon which is connected with a methyl. So this is having differently substituted bonds. This is also having differently substituted bonds. I'm not saying it will always be a optically active molecule. Why? Because, sir, it is, sir, having geometrical stereo center will always make me geometrically active. No, sir. I should have differently substituted bonds also. Similarly, having optical stereo center, a chiral center, does not mean the molecule is also chiral. Because sometimes if I am rotating light in some direction, you can rotate light in another direction because we have same components. So I will rotate in plus 30 degree, you can rotate in minus 30 degree. So that means sometimes if the molecules are symmetrical, even having optical stereo center, even having a chiral center will not make the molecule chiral. Chiral molecule as an optically active molecule. So you may have chiral center. Chiral center has an optical stereo center, but the molecule may become optically inactive. So if a molecule becomes optically inactive because of itself only, although it is having chiral center, but even if it becomes optically inactive, then such molecules are called mesoform. Sir, I didn't get it. Obviously, we'll discuss element of symmetry and we'll discuss those mesoforms more in detail. But here, with this question, we are just learning chiral carbons, so linking everything with it. So this is definitely having chiral carbons. So first is having 0. Obviously, we got our answer beta because none of them is giving 0 as option. So we definitely got our answer. Second one is having 2. Let us explore. So this is also chiral. This is also chiral. You can definitely check CH2, but sir, this CH2. So this is also CH2, this is also CH2. No, go to next point of reference. So it is actually connected with a 6-member ring. It is connected with a 5-member ring. So this bond and this bond is definitely different. And this is connected with a carbon which is connected with 2 different CH2 groups. So obviously the environment of this and this are different. Whenever 2 rings are fused through 2 carbons, those 2 carbons will always be optically the center will be chiral center. I hope you're getting this. You may have a optical stereo center, but the overall molecule may or may not be optically active. So right now we are just discussing chiral centers, chiral carbons or chiral centers. So it is having 2 chiral center. Okay, sir. Sir, you already told us. So that means that this is one of the chiral center. This is because they are fused. So this is another chiral center. This is because they are fused through these 2 carbons. You can definitely cross-check that these 2 carbons will always have differently substituted bonds. If you just keep on going till the point of difference, you will obviously find a point of difference. So that means answer is 50% are right. So good. Moving to the next one. Quickly do this one. I will attempt this with you so as to maximize some time efficiency. Now, sir, if X is chiral center, then find the value of X. Okay, so you just have to calculate the chiral centers. Okay, sir. So benzene, so sp2 hybridized, this is CH2. So no, sir. Sir, this carbon, this ring I, and it will have H also. So this is first chiral. Sir, this is sp2. So benzene ring gone, benzene ring gone. Let us just draw them. No. So that because there are many carbons, no. So whatever we are discussing, because these are all sp2, that one was sp3, that is definitely chiral. Now what else? This one. Sir, benzene, C. So this is also chiral. This one. Yes, sir, this is also chiral because it will be having H also. Then nitrogen. Beta, the lone pair on nitrogen will be delocalized. Sulfur was also getting delocalized, but after that also it was having 3 differently substituted bond with a lone pair. Its lone pair is not there permanently. It'll be delocalizing in the ring. So let me draw this with different pen because this is a good logic. So these lone pairs will be delocalized, sir. They will be delocalized due to resonance. So this nitrogen will become a double bonded nitrogen, and that double bonded nitrogen will have a plus. So it will be trigonal planar, sir. It may acquire a trigonal planar arrangement also. So that means this is not permanently having this lone pair. Sulfur also was having delocalization of the pi cloud, but it was having of the pi cloud lone pair. It was having permanently. That lone pair was not delocalized. I hope you get it. So sir, nitrogen, and technically I'm telling you also because that is also common sense which you should have, but yes, not for mains level of examination, but for advanced technically, if you just see nitrogen having lone pair, whatever 3 bonds it will have, let's say they are different, H, R and R dash, still beta, whatever. So technically this is also having same because now the nitrogen is not getting delocalized. So sir, this will also behave as a chiral center. Lone pair, sir. Sir, hydrogen R and R dash. Sir, you said like it is also having tetrahedral geometry like an sp3 hybridized carbon, and sir, or are differently substituted bonds. Then sir, this will also be a chiral center because this can also beta technically yes, but optical isomers are two different compounds. Sir, conformers, why conformers are not true isomers? Because they are interconvertible. Similarly, amines, this nitrogen, this is also nitrogen having whatever substitution, even if they are different, its isomer, or rather simply writing, they are interconvertible. And because they are interconvertible beta, that means the difference of potential energy is very less. So because they are interconvertible, that means they are not two different compounds, and optical isomers are two different compounds. That's why amines we do not considered as chiral center. Sir, shall we keep this thing in mind? Yes. Not very much famous for mains, but yes, definitely you should keep this thing in mind. है ना? चलो. So obviously that nitrogen though, it is also delocalized. So lesser it will be trigonal planar also. So leave it. Huh. I hope everybody is good. Sir, this is a chiral carbon because OH, a nitrogen, carbon and an H. Sir, this will obviously be a chiral carbon. Sir, this will obviously, because this is bridged between two rings, fused between two rings, and obviously this sulfur also we know is chiral. So 1, 2, 3, 4, 5, 6, 7. 7 is your answer. A good one. A good one. Definitely question gives us loads of confidence. So I hope everybody is clear. I'm just stopping to answer some questions if you have. Else beta, please practice these questions and revise these questions. It will help you a lot. Giving confidence, it will definitely give a great amount of confidence to you, because organic NCRT everybody can learn yaar. The only problem they face is relating with GOC basics. So discussing GOC basics so that it can be related with NCRT. Cool. Sir, first attempt था 12th के साथ. Okay, Neha, okay. I superstar. Remember na Neha? That's your name, superstar. You are actually a superstar. Chalo. I hope everybody is done with this. My luck students, confirmation beta I need. Whoever has still not gone for lunch break. Nahi, nitrogen isn't counted as chiral, Archana. Nitrogen isn't counted as chiral, Archana. ठीक है? Cool. Waiting for some confirmation, guys. Waiting for some confirmation, guys. Yug Pratap Singh. Hello, beta. Laksh Warriors. Waiting for confirmation. I will not move forward. Krupa, thank you. Chalo. Quick. Next one. Quick. Next one. Total number of chiral center. Same thing. Total number of chiral center. This is the first one. So, sir, this carbon is having both methyl, sir. So gone, sir. This is obviously chiral. This is obviously chiral. So this is having 2. Sir, yes, double bond. This and 1 will be lone pair. So yes, chiral. This is definitely carbon, which is chiral. This is definitely carbon. Rest are CH2. So this is having 3. Now, the last one, sp2, sp3, but hydrogen same. So this is having HCl. Okay, these groups are same, sir. The complete group are same. So hence, this is having 2 different same groups. So no, 0. So 2, 3, 0. 4. 33%. Great. Krupa. Awesome. Moving to the next one. Quick. Sir, identify number of chiral carbons in the following. So, the first one. Sir, sp3 same. So CH2 same. Yes, this will be chiral. Yes, this will be chiral. So two chiral centers. So two options gone. Then what about this one? CH3, CH2, this C, H and Cl, what's this? Array, sir, this is also CH3. It is just drawing CH3 differently, but this is also CH3. So no chiral, so that means this is 0. So obviously we have our answer, but let us check for this also. It must be having one chiral. So CH3, CH3 same. So no, this is not chiral because these are same. Then what about this, sir? HCH3 ethyl. This is a chiral carbon. Why? HCH3, that is ethyl, and this is cyclopropyl. This is isopropyl. Only one chiral. So obviously answer is 3. Answer is 3. Less percentage, but I hope. That's why I'm practicing questions also in this class, but I'm making you practice questions because I definitely know if I give this as a homework, nobody attempts. I have seen that performance in the previous class. You have only attempted those questions even while revision also, which have made you attempt in the class. So actually, let us understand this. We have to attempt more and more questions. Hence, an extended class was required, beta. है ना? चलो. Chalo, great. Moving to the next one. Now, not giving you a poll for this one because actually this is a question, an integer type question वैसे. Chalo, let us give a poll. Integer type poll. The question says, how many of the compounds contain chiral atoms? So you do not have to give me number of chiral atoms. If a molecule is containing chiral atom, chiral center, you just take it as 1, 2, 3, 4, 5. है ना? So sir, nitrogen, yes, definitely sir, because nitrogen lone pair was making the interconversion because lone pair flips and interconverts itself. I am not talking about the ammonium cation. So sir, this is an ammonium cation. The lone pair make the switch, sir, not otherwise. So this is obviously chiral. So in nitrogen, the lone pair makes the switch, the lone pair makes the flipping, and because of that flipping, the optical isomers of amines, of substituted amines, remain interconvertible because of the flipping made by lone pair. So if lone pair is gone, sir, this is a chiral carbon, a beautiful example to give a distinction between them. So this is definitely chiral. Sir, obviously this is also chiral, sir, because again, sp3 hybridized system. Sir, this is definitely chiral, sir, HOH, double bond and this, so this is definitely chiral. So third tick, sir, sulfur, yes, this will be in conjugation, but to hell with this because lone pair is still existing, which will be restricting. Sir, 1, 2, 3 bonds. So the lone pair is always there. That means that only nitrogen lone pair flips. Yes, not otherwise. No. So chiral center. Sir, phosphorus can have this, but sir, ultimately still nitrogen will have 4 differently substituted bonds. So this is also chiral. This is carbon, sir. Obviously, this is chiral, sir. No, sir. Two groups are same, sir. So I'm sorry. Sir, two groups are same, sir. So I'm sorry. So how many? 4, 5, 6. 6 are chiral. I mean, having chiral centers. Great, Archana. Awesome. Everybody. Acha, sir, you were just trying to discuss those questions so that we can correctly jump to the relevant question of JEE mains because mains also ask. Yes, definitely it does. So, master, this is what? Integer type. Yes. 45 seconds. Quick. You have to tell me the total number of compounds. The same question. The total number. Neha is saying 5. Prajal is saying yes, sir. Pranjal, great beta. Neha, Pranjal, Kotin, Jay with me officials, Raj Rani, Yug Pratap Singh, MHTC, and obviously my Lux Warriors. Great. The electricity is not coming here. Maybe we want to extend the session because my backup will die then. So let's hope. Let's see what nature wants from us. And a more extended session or a crisp one. So this is now on nature, not on us. Anna? Chalo. I hope you guys have attempted total number of compounds with chiral carbon atoms from the following. Okay, sir. Sir, technically, sir, this is sp2, sir, so leave. Sir, you can check this. Sir, CH3 as in methyl group. Sir, hydrogen. One is this, one is, yes, sir, this is definitely chiral, sir. No, sir. Sp2, sp2, and this is having CH2, 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 so no chiral. CH2. Beta, if you have any carbon with two same bonds, then how can it be chiral? So CH3 gone, gone. Sir. This C, one H, one NO2, one COOH. So this is chiral. Yes. So 1, 2. No, no, yes, H, Br, but one is CH3, another is also CH3. So this carbon is having two same bonds, so not chiral. So this carbon H, I, methyl and bulky group. So yes. Sir, HOH, alcohol or ethyl. So yes. Sir, IH, methyl and some more things. Sir, this is also chiral. So it is, although molecule is having chiral center, so just it. Because it is saying chiral carbon atoms. Optical activity may be there, may not be there. So if I have a chiral carbon, then I may be optically active. Like geometrical isomers, if I have a geometrical stereocenter, I may be geometrically active. But geometrical isomers, we know how to check. Optical isomers, sorry, optical activity can only be determined through experiment. Yes. So technically you do experiment and you check that whether you are optically active or not. If you are having optical stereocenter, by looking at you, I can say you may show. Whether you are showing or not can only be determined through experiment. Then we'll do some conceptual understanding around it, but this is the basic ground rule that you should know, है ना? चलो. So 1, 2, 3, 4, 5. So 5 is my answer. So 5 is my answer. Great. Chalo. Moving to the next one. Quick, beta, the same question, integer type. Acha sir, that's why these type of questions come na. So that's why you are making us practice these questions. Yes, yes, yes. Masha, po, gu, Masha, gu, pogu, Akshay. Tongue twister name you make as your username. JEE Warriors, eh? Continue. Yes, beta, I'm continuing. I am saying I will continue. The point is, this Sunday, my studio is having no electricity. Initially, it was. So I'm just worried about the backup, that how much backup I can have of through my batteries, my electrochemical cells. I have two huge electrochemical cells, by the way, but the consumption is also great. So I want my electrochemical cell to turn into an electrolytic cell so that when electricity comes, so the charging can start. Chalo, let's see. People are answering. Sir, sp2, so leave, sir. Sir, ch2, so leave, sir. ch2, so leave, sir. sp2, leave, sir. Master, one you got, sir. Sir, ch3, one this, one that, and one will be hydrogen. Sir, this is sp2, so I'm sorry. Sir, ch2. Sir, you are sp3 and bridged. You are sp3 and bridged. Bridge as in you are a carbon which is bridging between two rings. So definitely you'll have different environment. You can always check such options. Just draw the structures, you'll get it. Draw the structures as in what? So connected with CH2, connected with C, which is some CC, connected with C, which is methyl and some CC, and this is also having hydrogen. So 4 differently substituted bonds, obviously. So CH2, so because 2 H same, so gone, sir. Sir, got it, sir. Sir, got it, sir. Got it, sir. CH2. So just count the stars. 1, 2, 3, 4, 5, 6. 6, sir. Acha sir, mains is so easy, but yes, you have to practice accordingly, else you will not feel that level of ease. More JEE mains. Quick. But yes, I am giving you time bit also, so that you can at least draw and check. Hai. You can draw and check for yourself. Quick. Sir, observe the structure. Okay, beta, observing the structure. The total number of structures, yeah, compounds which shows asymmetry. So again, chiral center you have to see. Chiral center, na compound is chiral compound or not only determined through experiment. I'm again and again repeating it because students get confused. Chiral center is a basic criteria. You may show optical, you may be optically active if you have a chiral center, but yes, if you are, or you are having some problem within yourself, that can only be determined through experiment. So chiral center are like having members in a family which has an ability to earn, but whether the company on the by the end of the month the family will be having some extra savings to put in their bank accounts depends upon the situation. So having earning members are like chiral centers. They can earn, they can have a tendency to rotate a plane of polarized light, but after showing that tendency practically, whether so maybe your tendency is getting cancelled out by something else. So practically if you are optically active or not can only be determined through experiment, है ना? Chalo, so sir, this is obviously chiral, sir, because Cl, H, methyl and ethyl. So one is you got this is CH2, then you have nothing because nitrogen obviously lone pair obviously do flipping, and obviously here the two groups are also same. So do not see nitrogen. Yes, sir, this carbon, so NH2, OH, this carbon, and then hydrogen. So this is also chiral, sir, center, chiral center. Obviously, sir, this has all planar species. Some methyl, this is chiral. This is chiral. 1, 2, 3. Yes, this is chiral. Although it is having 3 centers, but ultimately chiral center that is also having. This is also 3. Easy, sir. Mains is easy, sir. Yes, great. So I hope this will give some confidence also. So 1, 2, 3, na? Haan. Chalo. Quickly, last 2 questions and then we'll be moving to elements of symmetry. Last 2 questions and then we'll be moving to elements of symmetry. Quick. Sir, the number of chiral atoms present in the molecule given. So you have to give me the number of chiral atoms present in the molecule. Okay, sir. The number you have to give. So again, a JEE question. So giving time. Quick. Quick. Chalo, I hope you got it. Now, sir, CH3, CH2, sir, this carbon. So one methyl, one H, one CH2 with nitrogen directly, one CH2 with nitrogen, obviously with some long route. So this is chiral, sir. This is chiral, sir. Then CH2, 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 CH2. Sir. C, nitrogen 1, some carbon other, some carbon this, and some and one will be obviously H. Yes, sir, chiral, sir. What about this, sir? O, some carbon with nitrogen, some carbon with benzene, and obviously H, sir. Okay, again chiral, sir. So 1, 2, 3, 4, sir. Now all benzene, CH3, all benzene. Sir, and this one, sir. Carbon, H, CH3OH. Okay, so 1, 2, 3, 4, 5, sir. So this is just a visual question, beta, after you gain confidence. Great. See percentages all. Chinmay N, you do not come to live classes a lot. Last question. Last question, and please read the question. Intentionally I've kept this question after JEE questions, because once you gain confidence from JEE questions, you also start doing incorrectly in JEE also. So this is how JEE tricks you. Read the statement of the question, beta. Sir, I am from Laksh batch. If you recall, I got excited from the class on the app and unable to attend polls. Acha, I got exited from the class. I'm sorry, beta, I read excited. So Ashrita, acha, Linka, yaar, Linka, you just write. I know you people by names. Okay, Rishabh. Rishabh, Neha is a superstar, so don't worry. Neha, I know. I've communicated. Rishabh, Neha is a superstar. Don't worry. Chalo. Uh, Sir, number of stereo centers in the given compound, sir. Okay, beta. So CH3 leaves, sir. CH2 leaves, sir. CH3 leaves, sir. Sir, C, sir. Ethyl, sir. Some bulky group, sir. CH3 and one H, sir. Chiral, you got, sir. Okay. One stereo center I got. Sir, C, sir. OH, sir. Some ISO 1, 2, 3. No, not ISO because some carbon chain. OH, some double bonded carbon, one H. So this is also chiral, sir. Now, it is saying not chiral beta. The only reason I said read the question because once you do those questions, you start assuming that it is written in the question. Is the question saying chiral center? No. It is saying stereo center. It is saying stereo center. Sir, stereo as in geometrical also, optical also. So optical you are seeing. But sir, C double bond C is a geometrical stereo center which has two different carbon as stereo centers and both of them should be differently substituted. So double bond C double bond C is a geometrically active stereo center, but C double bond C is having two different geometrical stereo centers. Both the carbons decide that if my groups are same or different. So if the question is asking you stereo centers, then definitely because this is a geometrical stereo center and this is also a geometrical stereo center which is having one H and one differently substituted bond, one H and one differently substituted bond. So this is also, let me make that with different color. This is also, and this is also a stereo center. So one geometrical stereo center has two different carbon as acting as geometrical stereo centers. So you have to count both of them. You have to count both of them. That is the only reason I have just brought this question separately after your mains level of questions, because it is asking for stereo centers, and a geometrical stereo center, which is a double bonded carbon, it has two different centers whom you have to watch. I hope you're getting it. So 1, 2 are the optical stereo centers. They are one center only, but geometrical stereo center have two different centers. So 1, 2, 3, 4. Then, sir, nitrogen, we know, sir, this lone pair can do flipping, so we don't consider, sir. CH2, CH2, CH2. So gone, sir. So yes, sir, this. Nitrogen, CH2 with a carbon having methyl, CH2 with C having methyl. So this is one will be H. So this is also chiral. So 1, 2, 3, 4, 5. Acha, you can also check this now because this is CH2, this is CH2. Sir, this will be no. This will also be chiral, and sir, this will also be chiral. So 1, 2, 3, 4, 5, 6, 7. So you have 7, I guess. I guess answer is 8. So are we missing any? Just check everybody, because I have 8 written as an answer. I have 8 written as an answer. Okay, good one, beta. Yes, good one. I have 8 written as an answer and it is good one. Sir, why? Nitrogen lone pair can flip, and hence its isomers are interconvertible, and hence it is optically inactive. This we have seen also. Is the question asking you optically active compound? Statement, sir. Is the question asking you optically active compound? It is asking you are having that stereo center. You may be optically active, you may be geometrically active. Are you a geometrical stereo center or an optical stereo center? You may be optically active, you may not be optically active. Is it asking you chiral compounds? It is asking you chiral molecules. It is asking having chiral center or stereo center, not only chiral but stereo center, hence included geometrical stereo centers also. It is asking center. Yes, sir. It is a stereo center. Yes. If it goes in nature, then because both of the form exist, so obviously equilibrium will exist. So 50%. Let's say the both the brothers having clockwise rotation and anti-clockwise rotation. So one component is rotating plane of polarized light in clockwise, another is rotating in anti-clockwise. So ultimately both are existing simultaneously because both are interconvertible, so light is not getting rotated. But it is the question asking us optically active compound? No, sir. It is asking stereo center. Yes, sir. It is a stereo center. Aha. Aha, I hope you're getting it. I hope you're getting it. Then, sir, why you have not done in the previous question? Because over there, nitrogen lone pair was getting delocalized. Over there, nitrogen lone pair were getting delocalized. A good one, a good one. So, this is also a yes, it is a stereo center. Although not capable of making an optically active compound, but a stereo center. So yes, answer will be 8. Good beta, good one. 1 2 3 4 5 6 7 8. Yes, sir. Good one. I hope everybody is clear. I hope everybody is clear. Chalo. So Rishabh, I hope you are also clear, beta, because you wrote 6. Chalo. Perfect. Perfect. Great one, beta. Now moving to, acha, let me see some. Uh, Chalo. So none. That was a good one. है ना? Chalo. Let's move forward, sir. Next thing is beta, the elements of symmetry. Whatever I was saying, that if, sir, geometrically active or not, we can just check by looking at the structure. If you are having geometrical stereo center as in a restricted rotation, I may be optically active, I may be geometrically active, I may be geometrically inactive. That I can see if you have differently substituted bonds. Done, sir. But sir, if you have optical stereo center, then whether you show optical activity or you do not show optical activity, that can only be determined through experiment. Agreed. But after doing that experiment and checking for every species, we found that all the species which are having optical stereo center, which are having capability to rotate the plane of polarized light, they were having no element of symmetry. And hence, even if a molecule is having chiral center, but still having some element of symmetry, then those chiral center become unable to actually rotate the plane of polarized light. So after doing experimentation and checking that you have chiral center, but still you are not able to rotate the plane of polarized light, then I have digged inside your geometry and saw that okay, you are possessing some element of symmetry. And if a molecule having chiral center possesses element of symmetry, then overall you can't show optical activity because you are not asymmetrical, you are having some element of symmetry. That means now we have to discuss the elements of symmetry that a compound can have, because this will give us a theoretical understanding without doing the experiment. This will give us a theoretical understanding without doing the experiment, because optical activity can only be determined through experiment. Sir, did and done those experiments, sir, and now generalizing, sir, that if as a molecule I have chiral center, but if I also have element of symmetry, I can't show optical activity. Not very bad thing, but still. Okay, sir, what the hell are these element of symmetry? Let us directly go to solid state. Let us directly go to solid state because it will help for doing good questions of solid state also. Very easy, very briefly, very beautiful photo made by your master's hand, but obviously making photo in a class will take time. So master has done the photo uh, session on my tablet and pasted those photo here. So I have invested time for the class beta. So Laksh Warriors, after the class you have got ratings, and YouTube JEE Warriors, after the class, please, I mean, yes, we are not supposed to say like, subscribe, but please do like, no, not saying, whatever you feel. Chalo, now, master, Master, let me just decrease the brightness because else it will be making your eyes uncomfortable. But yes, beta, make sure you remember, you make me remember after the 2 slides are gone, sir, increase the brightness, है ना? चलो, thank you, Krupa. चलो, total elements of symmetry are 23. Sir, technically these elements of symmetry we have gathered from solid state, and obviously as a solid, the compound as a three-dimensional structure, even I am a gaseous molecule, but if I'm doing your spectroscopy, if I'm doing the spectroscopy even for a tetrahedral carbon, the carbon will have a three-dimensional orientation. So very minute molecules having three-dimensional orientation can't be properly seen, so let us do it on a macroscopic level. So on a macroscopic level, what structure you have, sir? Solid. So solid state tells us that a compound can have in total 23 elements of symmetry. So first, what is the total number of element of symmetry? 23. Now, what what are the different types of element of symmetry? The first type of element of symmetry is center of symmetry. The name is also telling you what is center of symmetry. Sir, if you are moving from one end, passing through the body diagonal, and if you are meeting the same environment once you are moving along the body diagonal. Why body diagonal? Because body diagonal will keep you to the origin of 0, 0, 0 in a 3D plane. Like for example, let us assume a three-dimensional plane. Sir, x-axis, y-axis, z-axis. Now let's say I have this box. At the center, sir, if I move from this end and through following the body diagonal and I reach this end, so from this end reaching to this end, sir, I will pass through the center, and sir, this corner, not center, sir, this corner and diagonally present this corner is the same environment. So from the center 0, 0, 0, from the center 0, 0, 0, if I'm moving diagonally here and diagonally here, I'm getting the same environment. Again, you can go from anywhere. So technically how many center of symmetry you will have? Array and master, just one, sir. That is the origin, sir. So your center of symmetry is just one, and where it is located, sir? It is located in the body center, sir. It is located in the body center. So the first element of symmetry is center of symmetry. How many center of symmetry a system has? Only one. Now, a solid system. Then we have, sir, plane of symmetry. How many type of plane of symmetries? We have two types. You have a rectangular plane of symmetry. You have a body diagonal plane of symmetry. Sir, what is this rectangular plane of symmetry? If you just join a plane, how to draw that plane? Joining edge center of opposite edges. Sir, show us. But obviously beautifully I've drawn. This is a cube. Sir, edge center of the opposite edges. If you just connect them, you will get a plane. That plane is what, sir? It's a rectangle. And if along this rectangle I am cutting this body, then it is making two equal halves, two symmetrical equal halves. That means this is a plane of symmetry. What type of planes are? A rectangular plane. How many types of rectangular plane of symmetry a 3D object can have, a 3D cube can have? So 3. So this plane which is YZ plane, so this plane which is XY plane, and this plane which is XZ plane. Obviously, how many planes you will have? So 3. So how many rectangular plane of symmetry you will have? 3. Sir, shall we draw this, beta? Yes, clearly draw them. Try to invest a bit of time in them. Once you draw them once, you will keep them in your head for longer duration for a quick review. But yes, for once, I'm definitely suggesting please draw them. So this is your PYZ, this is your XY, and this is your XZ. I hope everybody is clear now. Sir, can we draw one more plane? Yes, you can also draw a body diagonal plane of symmetry. Sir, how to draw this body diagonal? Beta, you can draw a plane containing diagonally opposite edges. Containing diagonally opposite edges. Now, sir, but the photos are obviously body diagonal plane of symmetry. Body diagonal, plane of symmetry is pos. So plane of symmetry is pos. So body diagonal plane of symmetry, sir. Okay. Sir, cube, sir. Sir, this and this. Body diagonal as in through the body diagonal, I am joining this edge and the body diagonally present edge with a plane. So this will be a body diagonal plane, and obviously if you cut this, sir, upside you get a prism, downside also you get a prism, sir, same prism. So that means this is also equally dividing the molecule in two halves. Yes. So how many types you can have for this? So let's say 1, sir, this is 1, sir, this is 2, as in I have considered that plane. Now what about the other one? Sir, this and sir, this second one, sir. And what now, sir? Sir, this and this. So how many body diagonal plane of symmetry you can have? Sir, 6. Sir, shall we draw it? Beta, if you draw it just once, no, I am not saying it is very, very important for mains. Not at all important for mains. But yes, for advance also, it will help you like anything. So at least just do the drawing for once. For this class, after the class, revise and do the drawing just once. It will give confidence, that's it. Because common sense, it helps us to evolve common sense. Solid state is a chapter which help us to sharpen common sense. So for common sense, it is good, hai na? So 6 plane. So that means how many plane of symmetry now we know? Beta 1 is center of symmetry. How many center of symmetry a cube has? 1 only. So then we have plane of symmetry. How many plane of symmetry a cube has? Sir, a cube has 2 plane of symmetry. Sir, rectangular plane and body diagonal plane. 3 rectangular plane and 6 body diagonal plane of symmetry. So that means 6 plus 3 is 9. 9 plus 1 is, sir, 10 element of symmetry I know, sir. What else, sir? Then we have axis of symmetry. Now, how we define this axis of symmetry? Obviously, the name is telling you, you choose any axis. And along that axis, you rotate your cube. If after rotating your cube, you are getting the same cube in front of you, but whatever cube or whatever shape you are having, if I am choosing an axis along which if I am rotating that object and I am getting the same image of the object by rotating along that axis with some angle, that is my axis of symmetry. Sir, but the angle of rotation will also decide na? Yes. So that also further gives the definition of axis of symmetry. If I am rotating by an angle of 360 degree by n, then the value of n will decide the name of that axis of symmetry. Like for example, the basic example, there are if the value of, let's say, directly go to a picture. See, very easy. Sir, what is a two-fold axis of symmetry? What is a two-fold axis of symmetry? Also termed as two-fold axis of symmetry is also termed as C2 axis of symmetry. Let us not make this picture untidy. So two-fold axis of symmetry is called C2. Sir, how this 2 is coming? Sir, this n is 2. So if you put this n as 2, that means 360 degree by n, as in 360 degree by 2. That means C2. So C2, two-fold C2 axis of symmetry. That means my value of n is 2. Sir, if I put value of n as 2, 360 degree by 2 is 180 degree. That means if I rotate my compound with 180 degree along an axis and get the same image, that axis of symmetry is called C2 or two-fold axis of symmetry. Some references also use the word diode axis of symmetry. Sir, how to find this axis? For that I have already written that it is a body diagonal. That axis passes through the body diagonal. Let us see the pictures. There are 6 types. Sir, this is one edge, this is another edge. Now I am not passing a plane, I am passing a axis, a line. This line is drawn joining what? Sir, one edge center. Sir, another edge center, and I am joining these edge centers by passing a line through body diagonal. So written that completely over there. Axis passing through diagonally opposite edge center. Axis passing through diagonally opposite edge center. If you take such an axis, rotate the molecule with an angle of 360 degree by 2, that is 180 degree, you will get the same molecule. You will get the same molecule. Yes, definitely with 3D images we can show this with quite ease and comfort, but yes, that is a job we will do in solid state, not over here. Over here I'm just asking you to visualize this, draw this and practice by yourself. Obviously these days YouTube videos are very much available. Don't even if you find interest, you can. Else the basic thing that I'm giving you is you can have n fold axis of symmetry, and value of n is decided by the angle with which you want to rotate. So if along an axis I can rotate by 180 degree and can get the same image, so that becomes my C2 or two-fold axis of symmetry. How many two-fold axis of symmetry this cube is having? Sir, 6. Sir, one axis, obviously now you can just visualize this, and sir, if you rotate 180 degree you get the same picture. Sir, this edge center and this edge center, so this will be my axis. So along that axis if you rotate you get the same picture. So these are your C2 as in two-fold axis of symmetry. Sir, if I am rotating by 120 degree and getting the same image, then sir, but sir, 120 degree, how you are obtaining? Sir, we are obtaining 120 degree. One's value of n is 3, because 360 degree by 3 is 120 degree. So if n is 3, then this is termed as three-fold axis of symmetry, also known as C3, also known as triad axis of symmetry. So what is this axis? You can form this axis when diagonally opposite corners, which is body diagonally connected. Whom? Sir, diagonally opposite corners, body diagonally opposite corners. Let us see this. So this is one corner, this is body diagonally present corner. So if you just pass a axis through it, now you just have to rotate 120 degree. Just after rotating 120 degree you get the same image. Just after rotating 120 degree you get the same image. Acha, so that means how many types of axes we can draw? Beta, 4 types. So three-fold axis of symmetry, how many element of three-fold axis of symmetry exist in a cube? Sir, 4. So obviously the C2 is 6, C3 is 4, again going back, two-fold is 6, three-fold is 4, and four-fold is 3. You can learn like this. 2 is 6, so less value is more. 3 is 4, and 4 is obviously 3. As you increase the value of n, obviously the number of elements of symmetry will decrease. So last is four-fold axis of symmetry, obviously when value of n is 4. So if this is 4, that means you have to rotate by 90 degree. So how many such n-fold axis of symmetry exist? 3, which is called C4 axis of symmetry. So let us see them. So 3 exist. How you are drawing these axes? So you are simply drawing these axes by joining the opposite faces. Obviously every time I am passing through the body center. So opposite faces joined together through the body center. Sir, opposite faces, this is a face center, this is a face center, joined together through along the body center. So sir, this if just rotate by 90 degrees, sir. This is very easy. Just rotate by 90 degrees, sir. You get the same image. Just rotate by 90 degrees, sir. Sir, this one, sir. Let's say this is x plane. Let's say this is y plane. Then you will be having this as z plane. This one as z plane. So this is your z plane. So how many, sir? 3. Just rotate by 90 degree, you get the same image. Yes, definitely, because that's a 3D. So technically you just pass a thread. You just keep a box. I mean, the best way, even the better way than YouTube is, you just take a box like this. circle, at the centers, just pass a needle and then try to take a thread out of it. Now you just keep on rotating it. These things will be visualized by like anything, because then that ways you can easily make through a needle, you can easily make a hole and can pass a thread. So once passing a thread, just try to rotate it, you'll definitely see. Sir, why you have not done? Beta, obviously yesterday also I had 3 classes, and today I made such stuff. So definitely one day I'll do this. I'll make a short around it. But yes, for that I need some space of time. But yes, definitely a very easy job. But at least for making the video, it will take around half hour, 1 minute, 1 hour, because you have to show now, if you have to just see for yourself. So that's why I'm saying at least invest time with this. So how many elements of symmetry we have? 23. Please revise again, beta. Sir, we have 1 center of symmetry. Sir, we have 6 plus 3 as a 9 plane of symmetry. Out of them, 3 are rectangular plane, 6 are body diagonal plane, and the remainder are axis of symmetry. How many folds of axis of symmetry we have? 3. 2-fold, 3-fold, and 4-fold. How many 2-4 axes of symmetry? Sir, 6. How many 3-fold? Sir, 4. How many 4-fold? Sir, 3. So 3 is 4, 4 is 3, only C2 is 6. So in total, how many elements of symmetry we have? If you just add them, you will be having 23 elements of symmetry. Hello? Chalo. Now, sir, technically, this is not at all. None of the thing is required for your organic chemistry, even for advanced, because the basic element of symmetry that we just have to check is plane of symmetry for our organic compounds. Sir, please make us revise, because this is giving no confidence to us, sir. Although if some students are having interest in physical solid state, then you will be feeling very happy about it. Else for our organic chemistry, it is not even required also, beta. Then master, which element of symmetry is required to just see whether a compound is having some element of symmetry? 90% of your questions will be solved using just the concept of plane of symmetry, which is just a plane. Along that plane, you cut that carbon to that carbon molecule, and it will be having same half. So it will be divided in equal half. So for you, for mains, 100% of the time, only plane of symmetry will help. Let us practice directly questions around it. So that's why I've given direct questions, so that we can have that level of confidence. Okay, master. The first question, no time I'm giving. This is the first question. I will be having all the questions. You do not have to give me yes or no. You have to give me the number of plane of symmetry, because plane of symmetry is important, I told you. So give me number of plane of symmetry in the first compound. Give me number of plane of symmetry in the first compound. Everybody. Sir, what is plane of symmetry? Arey, come on, yaar. This much, sir, you have told us. Sir, this much you have told us, sir. Sir, you just have to select. Sir, you just have to select a plane. Cut it. The compound should be equally divided. Okay. Sir, come on, yaar, sir. Acha nahi, let's change color. Huh. See, guys. Passing a plane. Is it equally divided? Yes, sir. Passing a plane. Now forget this one. Passing a plane. Is it equally divided? Yes, sir. B are also there. B are also there. Yes, sir. Passing a plane. Is it equal to? Yes, sir. B are that side. B are that side. Yes, sir. Equal half. Sir, 3 I can see, sir. No. One more. Sir, because benzene is a planar structure, because this carbon is also having bromine in the same plane, because that carbon, sir, this carbon is tetrahedral carbon, na? Sir, this carbon is not tetrahedral, I'm sorry, sp2 hybridized, so trigonal planar. So these two bonds and this bond will be in the same plane. So if you just directly cut the molecule along this plane, sir, complete molecule is planar, you just cut along the plane, then what you had in that, what you have above the plane? Nothing. What you have below the plane? Nothing. So just cut the molecule, because complete molecule is planar. So just pass a plane along the molecule. So because complete things are in the same plane, so what is above the plane? Nothing. What is below the plane? Nothing. So nothing, nothing. As in, array sir, the environment is same, na? So it is having how many element of symmetry? Nah, nahi. 4, 4. Yes, yes. Perfect. So answer is Neha. Perfect. Neha has written 4, 3, 3, 2. So definitely, this is having how many elements of symmetry? 4. Check the second one, everybody. Check the second one, everybody. Check the second one, everybody. Chalo. Obviously, sir, this is also planar. So one plane of symmetry, so we can obviously see because now you have told us. So this is obviously one plane. What about another, sir? Sir, chlorine and bromine is different actually. So if you cut along this, no, sir, environment is not same. So no, sir. If I cut along this, no, sir. So Cl bromine, no, sir, not same. Are beta, cut along this, na? Chlorine, bromine gone because along this plane, whatever differences we have, they are gone. Here, so 2 carbon, here 2 carbon. Acha, master, 2. It is having 2 plane of symmetry because beta plane of symmetry is important. So at least visualize plane of symmetry. So Neha 4, 3. Yes, Neha 4 is right, but this is having 2 Neha. And Neha has modified answer. Great. Chalo. Next. This one beta. Obviously, one plane we definitely know. What about next? One plane we definitely know. What about else? Sir, what we definitely know you are saying, Array beta, complete molecule is planar na. So one is obviously this. Now, sir, obviously I can see one. Just pass through this, sir. There also one benzene here also because this is naphthalene. So one benzene there, one benzene here, sir, obviously. Sir, but one more, sir. You know what? If you just cut it through this horizontal center. So top also has these carbons. This also has these carbons. So this is having 3. You will not find any else. So that means we have to practice. Beta, practice some, then you will get a clear idea. Else permutation and combination can be applied in mind, but yes, that will be time consuming. But yes, invest that time. Hence taking a longer duration class. The last one, beta. Obviously, sir, this is just having that plane, sir. Just this plane, sir. Because if I choose any planar, any cutting through the molecules like this, that plane with the dotted lines, then sir, this will not find, no, because that is chlorine, this is benzene, so rings are differently substituted. So only one, sir. I hope everybody is good. I hope everybody is good. Now I am asking one extra question. Among them, not very much required, but if I ask you, who among them has center of symmetry? Now this is a question for you. 1, 2, 3, 4. Who among them, 30 seconds. 1, 2, 3, 4 as in ABCD. Who among them, question is, who among them has center of symmetry? Who among them has center of symmetry? Who among them has center of symmetry? Krupa is saying none. Obviously, I'm waiting because given just 30 seconds, so I'm waiting. Who among them has a child? Let me move so that you can see. Who among them has center of symmetry? Everybody. Think. Think. Who among them has center of symmetry? Think. Chalo. Time done. Actually, beta, answer is C. 33%. Acha, Archana. Why? Arey, sir, come on, sir. This much now we are hero, sir. Let me just draw that and make you realize that with different color. Beta, see, what is actually center of symmetry? So this is a complete planar molecule. So what will be the body center? So this will be my body center. Obviously, because this is just a planar body. So do I have, if let's say from this carbon I'm moving, and from this carbon I'm moving to this carbon along the body center. Do I reach the same environment? Yes. Can I repeat the same process? Yes. So is it giving me a center along which the compound is symmetrical? Yes, sir. So yes, it is definitely not sir, because there you have chlorine. So from chlorine, if you are moving here, sir, there is no chlorine. Sir, from chlorine, if you are moving here, sir, there is no chlorine. Bromine. Sir, obviously from bromine, if I move from bromine, I cannot see that bromine there. So that's why all of them definitely do not have center of symmetry. But this guy definitely has cos. Although POS is more important, cos is less. Yes, Neha, great. So moving to the next one. The next examples, beta. Out of them, how many? First question is you just give me plane of symmetry for each. For the first one, for the first one, yes, sir. Definitely, it is having one plane of symmetry. Any else? No, sir. Because otherwise, it is chlorine having there here. So it is only having one plane of symmetry. Now, is it having center of symmetry? Yes, sir. Why? Obviously, see, ClCl, HH, sir, passing through the center, sir. So this is definitely having center of symmetry. Yes. Now, obviously, the second one, how many plane of symmetry? And is it having center of symmetry? How many plane of symmetry? Acha, I guess, beta, this is the repeated one, na? So let's make chlorine here. Or else it will be same, no? We have already done this. So because chlorine were opposite, so let us make chlorine same. So if chlorine same, then obviously, sir, one is this. But sir, now this will also have a plane of symmetry like this. So how many plane of symmetry I'm having? Cos 2. Cos none. Why? Because obviously chlorine going along center, I cannot find that chlorine. Obviously, this also do not have any cos. This also do not have any cos. So here only this has cos. What about plane of symmetry? What about plane of symmetry? So this had 2. The seventh one. The seventh one. Yes, Neha, great. 1, 3, 4, 1. 1. This is not having 3, Neha. This is having 2. The seventh one. Yes, Neha is saying 4. So obviously, I guess everybody has seen. So this is one plane. Obviously, along this plane, if you cut, obviously it will be having hydrogen, but one hydrogen up, one hydrogen down. Hydrogens are also tetrahedral, so or carbon will be in the same plane. So the complete plane, obviously, cyclopropane is always a planar molecule. Sir, but sir, because it is, sir, having CH2, so sir, I can cut along this also. This will also one of the plane of symmetry. If I cut along this, it will again divide in equal half. If I cut along this, it will again divide in equal half. But sir, not center of symmetry, but this CH2 will meet in the median, which is not a carbon. So no center of symmetry, but yes, it will have plane of symmetry, and that too 4 plane of symmetries. So great. Krupa, 7 is 4, perfect, Krupa. 6 is 2, yes. 7 is 4, yes. Now 8th one. So Krupa is saying 8th is having 2. Obviously no center of symmetry, that obviously everybody can see, because Cl moving here will not find any Cl. And obviously 1 will be if you just cut along. Acha nahi yaar, Because this is a tetrahedral carbon, so one chlorine will be up and one hydrogen will be down. Nah. If you just cut along the plane, then sir, one chlorine is up and one hydrogen will be down, because this carbon is a tetrahedral carbon. So let's say if this is a wedge, then along dash you will be having H. So this will not have this plane of symmetry. No. But what we can do, sir, if we just cut, because chlorine is creating all the difference now, so just cut along this, sir. Just cut along this, sir. That will definitely give you a plane of symmetry, and that will be the only plane of symmetry. Just find any other plane. No, you won't find. I hope you get this better. With this cyclopropane, na, sir, it is planar. Definitely, carbons are planar, sir, but each carbon is tetrahedral. So tetrahedrally, one bond up, one bond down. So, sir, if one is Cl, then other is H. So if I cut along this, upside is having chlorine, downside is having hydrogen, sir, it is not symmetrical, sir. So this plane will not act as a plane of symmetry. So, sir, then cut this, sir. Pass a plane along this axis. So because that way chlorine will be gone, sir. And here also I have CH2, here also I have CH2. Here also you have, let me draw that CH2 with different color. Here also you have CH2 and here also you have CH2. I hope you're getting it better. So that's why it has only one plane of symmetry. Yes. So Neha great, Krupa great. Chalo. Awesome. Enjoying it, right? Beta, definitely common sense. I am discussing common sense here, which will make us confident for attempting a good advanced question. Again, I'm repeating, this is walking an extra mile. I could have avoided this walk, but beta, this gives a confidence that we are conceptualizing organic chemistry GOC logic for good questions of advance. So learning this way will enable to sit in a paper with confidence. I hope everybody is with me on this. Chalo. Moving to the next one. Some more examples. Quick, everybody. So, how many plane of symmetry the ninth one is having? Sir, obviously, sir, 1. Because now this plane will also, sir, because bromine is up. If you just cut along the plane, bromine up, down you have hydrogen. So that you have already seen, sir. So how many plane of symmetry we'll have? Sir, pos will be 1. We'll think of center at the last. So how many plane of symmetry? 1. Second one, no, sir. This will have no plane of symmetry. Why? Arey, sir, you won't find any plane, because if you just cut along this also, this bromine is up, that bromine is down. If you cut along this is having bromine up, that is having bromine up, but in another carbon. So it will have no plane of symmetry also. That means, sir, this carbon is having one CH3, one bromine, one carbon with the bromine, one carbon with CH2 and one hydrogen. So that means this is a chiral carbon also. This is also a chiral carbon and it is having no element of symmetry, sir. That means it will be a chiral molecule also. Without doing experiment, I am telling, it has chiral carbon more. See beta, if a compound is having only one chiral carbon, then obviously it will always be optically active, because a compound is having one chiral carbon. So if you just make my solution and make my solution go in that cylindrical polarimeter vessel, then sir, I will obviously rotate plane of polarized light. If a compound is having more than one chiral carbon atom, then there comes a possibility that maybe one chiral center can cancel another chiral center's work by doing opposite work. But if the molecule having more chiral carbons, more than one, but having no element of symmetry, then without doing polarimeter experiment, I can say that compound will be optically active. Hai na? Chalo, perfect. That is having no plane of symmetry. What about the 11th one, everybody? What about the 11th one, everybody? How many plane of symmetry? Obviously, sir, this molecule can't be used as a plane. If you just cut along this bromine, it is having CH2 here, yes sir, equal. If you cut along this, then you're having C with a bromine upside, C with a bromine wedge as an upside the plane. So sir, that is also symmetrical, sir. So how many plane of symmetry I'm having? Sir, pos, you're having 2. Now, what about the last one, beta? What about the last one? What about the last one? Arey sir, come on. If I nahi, this and this are same na. So let's do this because this is dash. So let me make this as wedge, or else there is no difference. I'm just modifying the question because this and this will otherwise will become same na. Sir, up or down hardly matters, no. So that's why I'm just changing it. So because that will become the same questions na. Now what is the case? Sir, if you just cut along this, now obviously this is CH2, this is CH2. So this is one plane of symmetry. And if you cut along this is upside, that is downside. So only one pause, sir. Even if you do this, here it was having two, now it will have only one, but ultimately having plane of symmetry is optically inactive. Okay. Now give me, okay, last thing. How many, which of them has center of symmetry? Again, giving you a poll for this. Let us do center of symmetry for 4 of them. So this is A, B, C, D. Consider this as A, B, C, D. So A, B, C, D, 8, 9, 10, 11, 12. Quick. Which is having center of symmetry? Sayyid Ali C. Krupa is saying C. Sayyid is asking, sir, where is electrochemistry? Although Sayyid has not written sir, Sayyid is just asking with an authority. I like that authority. That means you hold such authority over your mentor. So thank you, beta. Yes, definitely. He's just asking, where is electrochemistry L2? Where is electrochemistry L2? You have done electrochemistry L1, beta. I actually understand that. But beta, actually we see the way and the manner we come in YT platform is obviously to give and serve to more and more students. So students were giving me this feedback beta that they wanted more because I started with alkyl halides and hydrocarbons in the first class for this special series that we have launched at PWJ English. So people have asked for more of organic beta. So that's why this session is there. Yes, because Asif, I have considered your request as request number 1. So proportion definitely beta, I'll be doing it. But like you, I have to listen to more students na. Chalo. I will definitely do it beta in the following classes. Anna? Chalo. So let's check. I hope many of you, most of you have estimated that. Are none? Nahi beta, D is having, I guess. Krupa is saying C. Krupa is saying C or 11. Nahi beta. How come this C is having any center of symmetry? See, what is center of symmetry? Sir, if you move along, sir, this is a plane. So let's say here I have bromine and I have bromine in the this is the plane. So bromine as at the top, let's say here also bromine at top. So how you'd say center of symmetry, Krupa? So bromine through the center will move, sir. There it will have hydrogen, sir, because bromine is at the top, sir. So this will not none of them will have center of symmetry. Only last one. Let us check with different color. Only last one, beta. How? Arey yaar, sir, it is at the top. So just move through the body center. Then, sir, it is at the bottom. Sir, plane. One is at the top through the body center. Again, got bromine. Here also, sir, hydrogen, sir. So this will act as a center of symmetry. So yes, this will have cos. Rest, none. So cos cuttus, cos cancel, cos cancel. Only this is having center of symmetry. I hope everybody got it. Yes, Neha, great. Got? Kushal QMS was also saying C. Kushal, I hope. Kushal then changed answer D. Perfect. Chalo. Last 5. First, give plane of symmetry because this is also good. Because we'll not be doing photo, we'll be doing common sense. So first give me plane of symmetry and I'm helping you with this, that none of them has center of symmetry. So first give plane of symmetry for methane. So let us first do this for methane. Sir, come on yaar. Methane we know, sir. It is a tetrahedral system, sir. So 2 bond in one plane, sir. 1 bond outside the plane. 1 bond inside the plane. This is tetrahedral. Come on, sir. We know in tetrahedral 2 bond will always be in the same plane. Sir, cut along that plane. Sir, 2 bonds will always be in the same plane. So cut along that plane, sir. Let's say these 2 bonds are in this plane. If you just cut along, if you cut this molecule along the plane of the board, then sir 1 bond is up, 1 bond is down, sir, because both bonds are same, because all you have H bond H. So sir, you will have H there also, H here also, because tetrahedral is also symmetrical. So that means sir, every time you cut along a plane you will get a plane of symmetry. But sir, this is 3D. How we beta then calculate using permutation and combination maths? Nahin, Krupa, just do maths beta. Now chemistry ended. Now chemistry ended here for this question. You just have to see the permutation combination for those 3 H's, sir. Hydrogen, 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 hydrogen. Sir, 1, 2, 3, 4. So if I am considering a plane with 1 and 2, sir, this will give me 1 pos. Cut along 2 hydrogens which are present at 1, 2. Sir, 1 pos. Sir, then 1, 3, another 1, 4, another. So how many plane of symmetry you had considering 2 hydrogens? Sir, 3. But sir, more possibilities, sir. Because 1 we have counted. Sir, but 2, 3 will also give 1. 2, 4 will also give 1. But sir, one more, sir, one more. Beta 3, 4 will also give 1. Now you have no other possibility. So 1, 2, 3, 4, 5, 6, sir, it will have how many plane of symmetry? 6. Hi, master. Without drawing photo, sir, we got it. Nah. I need confirmation. This is good. Hi, Neha. Oh, Neha is just giving answer like superstar, yaar. Commendable, Neha. I mean, your dedication, I am a fan for it. Because you all Laksh warriors, I mean, my app students, Neha is, I'm just, because beta, you can parallelly see her. She is a student. Once we were having those neat lives, 5 hours, 6 hours, 7 hours, she continuously sit in the classes and she solve questions. So I have never seen, in fact, there are many lives where she was the only student. Like you can obviously see, beta, she is also a student now. So technically, but now people are 3 hour, 4 hour, and at the end of the year, once mains will, I mean, zone in, then you'll say, sir, one shot, then you'll study for many hours. But that many hours will not be constructive because you are not doing it with a fresh mind. So, but sir, discussing questions will require time. And even I was having this feeling, my dear Laksh warriors, that I was actually intending to give you the best of GOC in my classes. I did also, but yes, because I was giving more and more questions, and sir, obviously, if we practice all the questions in the class, it will take time. And that's why this extended session I have taken. Hai. So, but beta, that energy should be there. Only I guess Krupa is solving. So it's okay. This, we even helping one student, we are happy is our motto. Chalo. So everybody good? Chalo. At least we have more participants. So Ibrahim, welcome. Keep on solving with us, beta. So I hope this 13th is clear. Whoever is listening to me, please respond so that I can at least relate how many are there with me. I am waiting for confirmation from the students who are not sleeping. Quick. Else not moving. Else not moving. Quick. Not quack. Quick. Chalo, Archana is here. Thank you. Then we have JEE with me officials. Oh, JEE with me officials. But yes, thank you. Chalo. Next one, beta. Quick. The 14th one. How many pos? Answer. Arey, come on, sir. Now you have told us this. So because I have two bonds and one upside, one downside, obviously, sir, Cl I have to put in the plane, sir. You can choose among H, but Cl, because if you cut along the plane which is exactly having Cl, then only you will have HH, because Cl is a different species, you will not have it. So you have to cut along that plane which is definitely having Cl. So, sir, that means Cl is fixed, sir. You can just choose which H. So this will remain fixed. So you can choose this one hydrogen, or this hydrogen, but your plane should definitely have the Cl. So how many plane of symmetry I'm having? 3. I hope everybody get it. Next one, beta. CH2Cl2. I hope now this is a common sense, everybody. How many for CH2Cl2? How many for CH2Cl2? Yes. Obviously, sir, if you want, then for the two bonds that you have to pick, they should only contain HH, because upside downside will be ClCl, or they should only contain ClCl, because upside downside will be HH. So only two possibilities of POS will arise here. I hope everybody is clear. Now, what about this one? CHCl3. What about CHCl3? Sir, for CHCl3 also, sir, C, ultimately, sir, H is only making the difference. So now you pick a plane where H is fixed, sir. Now you pick a plane where H is fixed, sir. So then you can have whatever in the three things, because just pick a plane where H exists, because if H is gone, then you will definitely have 2 ClCl. So instead of chlorine, now you fix H, because now Cl, Cl, Cl are sufficient. So 1, 2 and 3. Obviously this is the same thing. So how many plane of symmetry you will have? 3. Moving to the last one, so the CCl4 is nothing but like CH4, so plane of symmetry will be 6. And obviously none will have center of symmetry. I hope everybody is clear. Chalo. Good. Sir, why Cl is in plane? We cannot place it wedge or dash. Beta, let me repeat. If you're asking for this, beta, then actually what is a tetrahedral system? Sir, two bonds in the same plane. You just pass a plane, you just cut this molecule along this plane. Which plane? Sir, the plane which is having this Cl and H. So what will be wedge and dash? Sir, because you only have one chlorine here, rest all are hydrogen. So you just cut this complete tetrahedral molecule within that plane which contains chlorine, because that is the only point of difference, because whatever two wedge and dash bonds you will be having hydrogen only. So for this, I'm just choosing a plane where chlorine is definitely one of the bond, and obviously in order to form a plane I want one more bond, so one plane will definitely be having hydrogen. One bond will definitely be having hydrogen. But that hydrogen can be of this x-axis also, y-axis also. I mean, in a 3D, there are 3 different types of hydrogen. So that plane can be 1, 2, 3. Cool? This is easy, sir. Chalo. So moving forward, quick questions. Then we'll do some JEE questions. Quick. 30 seconds. Acha, now I shall increase the brightness. Nobody reminded me of this. I told to remind me, because brightness then makes the class look dull. Quick, everybody. Number of plane of symmetry. Number of plane of symmetry which benzene has. Arey, sir, come on. Number of plane of symmetry which benzene has. So these all are CH. And obviously these hydrogens are in the same plane, sir. And then we have, sir, alternate pi cloud. Obviously it can be anyways. Arey, sir, every hydrogen, nobody is up, nobody is down, sir. Every carbon and hydrogens are in the same plane, sir. Arey, come on, sir. This is a easy thing, sir. But let us try. Obviously, if you cut along the plane, then complete molecule is planar. So this is one of the plane of symmetry. What else, sir? Then obviously, if I cut along this, this is one plane of symmetry. Sir, but if you cut along the middle, no, this will also have a plane of symmetry. I hope you're getting it. If I'm just cutting through the center. Why? Because this carbon equidistant, this carbon equidistant. So that carbon and this, because this is also center. I mean, just let me not draw like this because it is not giving a beautiful picture. Let me draw the structure like this. I mean, its center and its center. So this will also be one of the plane. So this is 1, this is 2, and obviously, sir, this will be 3. Acha, I have made my by hand, so that's why they are not meeting. So this is 3, sir. This is 4, sir. This is 5, sir. This is 6, sir. The center, and the 7th one, this is already the first one which I've counted. So this is the 6th. Now, if you start from there, so you have already included them. So 6 plane like this, and 1 plane is this. So 1 plane is this, and 6 planes. 1, 2, 3, 4, 5, 6. So total you have 7. And sir, obviously, if you move from one to another through this body center, then definitely, sir, it is having center of symmetry. So it is having 7 plane of symmetry, and definitely this compound will have a double bonds. Beta, double bond will have same bear. Pi cloud. So if you cut, it is just symmetric, na? It is just symmetric, na? Yes, beta, this lecture is more than sufficient, but yes, as I said, the nature will allow us to extend the class or not extend the class, and I definitely said double bonds. I hope everybody is clear with this. I hope everybody is clear with this, guys. Huh. So as I said, you can see with the this also that because we have cats and dogs falling in my district, so obviously the electricity is not there, and that's why I guess the backup is now telling me teen 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 teen. Let me make you toon. Can you see? Listen. So beta, I guess this will be instead of ending this abruptly. So let's call it a day. Yes, we will definitely be meeting soon, but we'll be definitely meeting very soon. But obviously, my Lux students will be meeting in the tomorrow, and we'll be continuing with this, and we'll try to connect in YT as well as soon as possible. So this is it for today's lecture, beta, because we have to wrap things up. So these are few homework questions for you, because I wanted to discuss, but yes, the questions we have done now, this will be very easy questions for us. These are directly PYQs. These are some direct PYQs. Yes, so you will be having some practice questions, beta. Yes, I wanted to make you attempt most of it, but I will be making the complete PDF available so that if you can completely read and try to attempt more and more questions. Obviously, the later questions we'll be discussing in the next class. Obviously, on Monday we'll be meeting, and my YT warriors, my YouTube JEE warriors, I will also be giving you these notes so that you can also practice these questions at your end, although there are some topics of optical isomerism which are still left, some good